Is my slide visible to you?
Yes, sir, visible.
Okay, thank you. Okay, once again, good morning to all of you and all the participants, all the respected faculties and the students. I myself, Dr. Robindro, and as introduced by Dr. Kundal, I have been here for last 15 years. And before that, I was in industry for 4 years. So I have total around 19 years of experience. Today, I'm going to talk about a topic on EV performance evaluation using drive cycle analysis as well as EV powertrain system. And this is part of the 5 days online Atal faculty development program organized by NIT Manipur. And the outlines of my talk, I will be covering the introduction and the motivation, why we need EVs and the other alternative vehicle technologies that are already prevailing in the market, and the vehicle powertrain systems, all the possible powertrain systems. And then I will talk about the practical case studies that we have done in our laboratory and the methodology we follow it. And then performance and drive cycle analysis using the chassis dynamometer as per the standard, and the technical discussion. And then I will cover the conclusion. Then if time permits, I will be covering the EV experiments using supercapacitors and the test facilities that we are using here. And then at last, I will cover the EV comparisons of 2-wheelers and the 4-wheelers. So my talk basically will be based on the practical and the hardware implementation. I will not be covering the basic fundamentals which have been covered by the eminent professors in the previous presentation as well. So I will be discussing more on the vehicle level, not on the subsystem level. Subsystem level are already covered by other experts. So I will be covering basically more on the vehicle level, what happens at the vehicle level after all the subsystems are integrated together and how they are working at the vehicle level. Then apart from that, as I am one of the member in the Bureau of Indian Standard and the Automotive Indian Standard, so I would like to update you what's going on in the Indian as per Indian standards for EVs. And to start with my presentation, so first is the introduction. So as you all know, that India imports 80 to 84% of total crude oil consumption. And for this, our Honorable Prime Minister and the present government is pushing all the stakeholders to cut down the crude oil import by 10%. It is a very huge target. And that's why the government has already launched the national flagship program called the National Electric Mobility Mission 2020 around a few years ago. Then under which we had the FAM1 of rupees 700 crore. Under the FAM1, all of you might have seen the e-rickshaws everywhere in all metro cities and the metropolitan cities. Now the FAM1 has been completed in 2019. Now, since last year, the FAM2, the second stage, is in process and is still going on with the outlay of 10,000 crore. So majority of this fund will be going for the infrastructure development. And basically this mission targets to have a sales of 6 to 7 million units of new electric vehicles as well as hybrid electric vehicles, along with the target resultant fuel saving of 2.5 million tons of the fossil fuels by 2022-2023. This that you get updated yourself from the website, from the FAM website. There is a very specific website which indicates how many electric vehicles are registered every day and till today, how much fuels are saved, that you can get from the website. And as on today, there are around 61 millions in use ICE vehicles in India. Out of this 61 millions, 7 millions are passenger. And then this is the current very hot topic for all over the world, that vehicle emission from all these all ICE vehicles are the major source of air pollution in Indian cities. And that's why the country's Supreme Court bans the sales of Bharat Stage 4 and 15 years old vehicles in India since 1st April 2020. So in metro cities like Delhi, Mumbai, nobody can. That's why this is a phase-wise, you can say, phasing out of the old vehicles. The overall objective of having all this agenda and mission is to have energy security for the country and to have the fuel saving as well as environmental friendly mobility. So air pollution is one of the major killers for human being. So it kills around 5.5 million people, mainly in China and India, you can say in every 5 years. So these are introduction and why we need electric vehicle in India. There are around 4 driving forces. So one is the Paris Climate Agreement, that COP21. So India being the one of the obligatory country, so we have an international obligation at international platform to meet some international target. Now COP26 is coming up in Glasgow in November. So all the world, the developed countries and the developing countries are eyeing on this COP26 meeting, which will be held in November in Glasgow. So there UN, that climate summit will be having some new targets as well as objectives that everyone is waiting for that. And the another second driving force is the ambient air quality concern, that like you might have seen from the news paper and all other electronic media, that air quality in New Delhi has been affected by other the air pollutants like smoke coming from other neighboring states. These are a big concern for the metro cities like Delhi and the other Kolkata, then Madras, so on and so forth. Then we need to reduce the import of oil so that we have the energy security for the country. And the last one is the trust on the renewable energy source like solar power as well as the wind energy system and their related energy storage systems. These are the all the driving forces that push for electric mobility. And the one motivation for going for EV is that urbanization and health problems. More than 50% of the world's population, which is more than around 3 billion people, they live in mega cities and metropolitan regions. So they are more susceptible to the pollutants caused by the many the sources like construction, then PM 2.5, PM 10, then vehicle pollutions, so on and so forth. You can see the one picture on the right side on the top, which shows 2 lungs, and one lungs indicates the lungs of a healthy person, and another lungs is the little blackened, and the this person has been exposed to a polluted environment. So you can see that how dangerous it is for a human being, and those who are exposed to a polluted environment for a longer period of time, then you may have lungs like this. So it is very dangerous for our health, basically for the people like traffic police and the those who are exposed to those environments. In India, you can see India is having a population of vehicles mixed with VS, starting from Bharat Stage 2, 3, 4. All sort of vehicles are mixed. You can see such scenario, Maruti car having such a smoke, or you can see auto rickshaws having such smoke everywhere in India. These are a very big environment concern for the residents of those cities. So it has to be taken care with other alternative means. Then other motivation and opportunities are, as you all know that global warming and climate change is happening right now. So you might have seen that wildfires and the unnatural, unusual floods and the polar ice melting. Then its repercussion is the food crisis, then associated health issues. These are the all impacts of the global warming and the climate change. You might have seen the unprecedented flood and wildfire and so on and so forth everywhere this year. So it was a huge loss for us, huge loss of revenue, as well as the income sources. Trillions of dollars is an unaccounted amount of money and resource has been lost to such impact of climate change and global warming. And opportunities are, we have the vehicle scrapping policy 2021 announced by the government of India. So from this, we will be having a very large amount of in-use ICE vehicles. Maybe some ICE vehicles will be as good as new one because they have been never used, but because of the aging problem, they may be going for scrap. So instead of scrapping, we found a solution that convert those in-use vehicles, those who are nearing for end of life, then convert them to electric vehicle. These are things that we have done as a case study in our laboratory, and that I will cover in the subsequent slides. Then one of the opportunities and the motivation for the researchers and stakeholders are the newly launched Auto PIL scheme, which has an outlay of 26,590 crore, and it was announced in September and having the gazetted notification on 23rd September 2021. So these are the opportunities that we can tap. All the stakeholders working in EV research, we can tap these opportunities and join the dots. So, and now we have this slide. Then I would like to explain that there are alternative vehicle technologies. These are for the fuel saving and to have a vehicle L5 reduction. So whatever we do in lab by the mechanical engineers having new engine, new fuel, new additives, so on and so forth, the ultimate target is to have the high fuel economy and then reduce vehicle emissions. These are the ultimate targets. That's why all the mechanical engineers, automotive industries are all revolving around. And then again, the new entrants like us, like you and all electrical engineers, they are targeting not using the fossil fuels like zero emission vehicles. So now there are around 4 main alternative vehicle technologies. The first one is on the left of, which are CNG, LPG, and ethanol. I think CNG, LPG are limited to some geographical location like Delhi, Ahmedabad, where you have the infrastructure, and the CNG, LPG is not applicable everywhere in India because of the limitation of the infrastructure. And then ethanol, government is pushing very hard for ethanol blending with the petrol. So now 20% has to be mixed with the petrol. That's why there has to be some trade-off between the supply chain. Otherwise, when we start consuming ethanol to burn to move the vehicle, then we have to compromise in our food chain, like sugar supply has to be balanced. That's why it is a very tricky situation. Then next come the second alternative vehicle technology, that is hybrid. Hybrid electric vehicles are those vehicles having two sorts of the powertrain system. One is propelled by the IC engine, one is the electric motor. So electric motor drive and the IC engine combined together, we have the hybrid hybrid electrical vehicle. So then third one is the electric vehicle where we don't have the IC engine, no fossil fuel consumption. So purely it is a battery power electric vehicle. So here we have the zero vehicle emission. Then last one is the fuel cell. It is ongoing research. It is in very initial stage. Fuel cell means your energy source will be hydrogen. Hydrogen will be stored in a storage tank and it will be carried on board like CNG tank. Then you have the fuel cell which converts the hydrogen into electricity. Then it can be either directly used to fire the electric motor, or it can be stored in a battery. And there is a different topology that we can have in a fuel cell. So these are the alternative vehicle technologies that right now all the researchers are focusing on. So with drivetrain and with vehicle technology gives the more efficient and more sustainability is will be the winner out of all these vehicle technologies. And now we will discuss about the different powertrain systems of a vehicle. So before we start talking about different powertrain systems, so I would like to inform you that my presentation will be mixture of videos to make you understand better. Then after an appropriate slide, I will share you some videos of the relevant slide. Then and then I will show you some videos of the laboratory testing also, where and how we do the EV testing in our laboratory on chassis dynamometer. So it will be, I hope it will be interesting. And at the end of my presentation, I would like to try my best to finish by around 11:30, so that we have 30 minutes for interaction and the question and answer session. Now coming back to the slide, then when we talk about the EV powertrain system, so we have to talk about its older siblings like ICE, and then parallel hybrid and power split, and the serial hybrid. For the ICE vehicle, so it is topology is very simple. You have a fuel storage, then IC engine. There is a fuel line and a fuel supply system, including the fuel pump. So it is a very simple from mechanical energy you are converting to the from chemical energy you are converting into the mechanical energy. So your fossil fuel is the chemical energy, then your fossil fuel is converted into the mechanical energy using the ICE, the internal combustion engine. Then we come to the parallel hybrid. In the parallel hybrid, we add one electric motor drive and its powering unit like battery and its relevant power electronics devices. Then we have the ICE with the electric motor drive. Then in this case, electric motor is just assisting the ICE. Here it is your drive shaft or your drivetrain is common and connected to both EV motor as well as ICE. You can see here, this is the, you can say drivetrain. I will call it collectively drivetrain. Drivetrain is common to both the propulsion system. Then now we come to the power split hybrid. It is similar to the parallel hybrid, but you add another EV motor drive system on the rear shaft. Rear axle. So this is not common because of the additional hardware and EV motor and its driver. Then you have to pay more. That's why it is very expensive. It is very it is not common. It is just for research purpose. Now we come to the serial hybrid. So you can see the difference between the serial hybrid and the parallel hybrid. In the parallel hybrid, your drivetrain is connected both to the EV motor as well as IC engine. Now you can see here in the serial hybrid, your drivetrain or your drive shaft is connected only to the electric motor or only to the electric machine drive. It is not connected to your IC engine. That is the difference between the serial hybrid and the parallel hybrid. So here IC engine is not continuously operated. It is operated as and when required to charge the battery or to fire the electric motor. Depends on your drive modes like sport, eco, and then highway drive, so on and so forth. Then at last we have the electric vehicle drivetrain. Here it is very simple. Your electric motor is directly connected on your the drive shaft. Then it is powered by the battery and its combination, maybe a hybrid energy source combined with the supercapacitor. So here electric vehicle powertrain I will be discussing different part and topologies. What kind of topologies that we can have for an electric vehicle, and how we can put the electric motors, how and where in which connection. So that we will discuss in a few slides. So here, to understand, to make you more understanding, I would like to show you a video of this hybrid powertrain, so that you can see the difference between the electric motor, electric vehicle, as well as the ICE and the parallel hybrid and the serial hybrid. I just like to share one video.
Sir, any problem, sir?
Video mode.
Is my video visible?
Video is visible and your slide is also visible, sir.
Video is visible, no?
Yeah, your video as well as slide is visible. No issue, sir.
Both.
You played one video.
Yeah.
No, that is your slide is powertrain system of a vehicle. That slide is showing. Just you may
Okay. Just
stop sharing and then you may play video.
yeah.
Just you stop sharing and again you start. That will be better, I guess.
Okay, all right. I will share you. I think there is some issue because I am not familiar with this.
No, sir, just you first stop sharing because your video is your slide is also visible. Just you stop sharing and then you may share an entire screen.
Okay.
In that case, it should come, I guess. You stop sharing, just click above, sir. The bar will go down. There you can stop sharing. Yes, now it is stop, sir. Now you again start sharing entire screen. It should work in that way, I guess. Is your video running, sir? Because I can see your page. You are muted, sir. You are muted. You are muted, sir. Unmute yourself, I guess.
Yeah. Can you hear me now?
Yeah. I'm able to hear you, sir.
Can you see a video on the truck?
We are able to see your screen where all the videos are there, like list of videos are there.
Okay.
reach, HEV. I think it is playing your side.
Yeah, I'm just, let me share again. Now I hope it is.
Yes, now it is, video is running.
Motors has developed this advanced
Voice is also coming, sir. It's good, sir. Now you can
plug-in series hybrid drive system. Designed to drive SUVs and light trucks under full electric power to achieve over 100 miles per gallon in typical local daily driving. The vehicle is propelled by a 200 kilowatt Cimatron enhanced AC induction motor and drive system designed by VIA Motors. It is one of the most powerful electric motors offered in a passenger vehicle today. The traction motor will also provide regenerative braking to help recharge the batteries and help slow the vehicle. The high-power Cimatron controller drives the motor at maximum efficiency using proprietary control algorithms. All vehicle systems are controlled by the hybrid master controller. High performance is delivered through a high-performance automatic transmission and transfer case, sharing power through the front and rear axles, maintaining the performance of full-powered four-wheel drive SUVs. Advanced technology lithium-ion batteries deliver 700 volts of DC power directly to the three-phase inverter, eliminating a DC to DC converter. High-power architecture helps improve system efficiency and reduce manufacturing costs. Liquid-cooled battery packs are safely mounted between frame rails to provide 40 miles of electric range under full electric power. They can be recharged conveniently at home using a standard 110 or 220 volt outlet. Batteries can also be charged rapidly and efficiently by the onboard 100 kilowatt Cimatron enhanced PM synchronous generator. The generator also provides direct power to the electric motor when the batteries are low. The Cimatron PM generator was custom designed to match the most efficient operating speeds of the combustion engine. This allows the engine to operate only at its peak efficiency range and only when needed to recharge the lithium-ion batteries. This is an electric vehicle with a range extender. Most SUVs and trucks of this size require a large V8 combustion engine. In VIA Motors' plug-in series hybrid architecture, the combustion engine is only used occasionally to recharge the batteries. A much smaller, more efficient 1 to 2 liter combustion engine can replace the stock 5 to 6 liter engines. The combustion engine is connected only to the electric generator and is not connected to the drive system. The engine is only used to generate electricity and to recharge the batteries when the vehicle drives beyond its 40-mile battery range. And when driving beyond battery range, a vehicle using VIA Motors' electric drive system should get twice the highway gas fuel economy over the base vehicle. This is primarily achieved by operating the engine only at its peak efficiency of approximately 30% to recharge batteries, rather than at the average of 15% efficiency when accelerating the vehicle. Advanced plug-in series hybrid drive system by VIA Motors will enable larger vehicles, including SUVs and light trucks, to drive up to 40 miles in all electric.
All right, I hope you have seen the video. Am I audible?
Yes, sir. Yes, sir. You are audible.
Okay.
It was
Right.
okay. We have seen.
So yeah, now let's go to the next slide. You have seen how the components are positioned for a vehicle inside their chassis, and how the subsystems are distributed evenly over the chassis of the vehicle. So now we come to the electric vehicle subsystem. So this slide gives you a brief idea what are the main subsystems of an electric vehicle. So you can see how the subsystems are integrated in an electric vehicle. You can see here the electric motor is on the rear side. So basically this vehicle is a rear drive vehicle. There are different drive modes. the front drive and the rear drive. So this vehicle is a rear drive, and the batteries are positioned on the middle so that your center of gravity is maintained. Then you have a AC blower, AC compressor, so on and so forth. Then you see the schematic diagram. This is the drive axle and your front wheel, and then you have the reduction gear, which is connected to the electric motor. Then electric motor drive system. Basically, it can be a vector controller or maybe scalar controller, a V by F controller. Then we have the battery. It could be a 48 volt or 72 or 96. Then we have a DC-DC converter from the higher DC to 12 volt DC voltage, because we need 12 volt for the vehicle infotainment and the vehicle other equipments like wiper, like horn, so on and so forth. Then one of the major importance for an electric vehicle is that we should have a very good electric motor selection. So when we do the EV motor selection, we should pay attention to certain factors like frequent start stop, high rate of acceleration and deceleration, high torque, low speed. For example, like in hill climbing, you need high torque but low speed. And for the high speed, you need a low torque but high RPM. And so on and so forth. Therefore, we need to have very wide range of operation for an EV motor. So among the EV motor classifications that I am not going to talk in detail, which has been covered by other speakers. So for our research purpose, we are using induction motor for many advantages. So basically for low cost and a rugged structure, because ultimate aim is to have an affordable and a viable electric vehicle for the public. So if we use expensive material and components, then ultimately our the vehicle will be more expensive, which may not be affordable for the public. That's why we go for induction motor, which is the very low cost. And this torque and speed characteristic curve is of a typical EV motor of an induction motor. So here you can see that in comparison with the combustion engine, so we have a very high torque at 0 RPM, unlike in the internal combustion engine. Internal combustion engine, you need a idling speed. Below that, your engine will stall and the engine will be off. So we need a minimum RPM which will be maintained always. So engine will be on always and fuel consumption will be there always, whether you move the vehicle or not. So that's why in the electric motor, we have the very high torque at a very low RPM. That is where the IC engine cannot compete with the electric motor. You might have noticed in the YouTube channels, so on and so forth, that Tesla Model S and Roadster can beat the Porsche 911, the fastest car, maybe Ferrari. For the first few seconds, there is no IC engine vehicles which can beat the electric vehicle. So for the first the few seconds, the electric vehicle is the fastest to reach the 100 km/h. So this is too fast actually for the initial starting. So these are the typical characteristics. So I'm not going to explain you in detail. These are the one of the motor that we are using. It is a typical characteristic curve for that induction motor. Then next important factor is that how do we do the motor sizing? EV motor sizing is very important because it should have the very wide range of torque as well as the speed for the on-road operation on different terrains. So, and then when we design the EV motor, we should consider certain factors like rated power, rated torque, and rated speed. So these rated power, torque, and the speed must be tested on different conditions, like on gradient, zero gradient. It is basically represents the flat surface. You have the 5-degree gradient, means little incline. then 10 degree, and 17 and 22 degree. So at all these conditions, your electric motor must be tested. So then you will be recording the maximum speed, maximum power, maximum torque. Then to achieve all those maximum the parameters, we need to have a suitable gear ratio. So then that is where your gear requirement of gear system is there. So we need a gear system which should be combined with the electric motor so that you have the optimum gear ratio to achieve all this maximum speed, power, and the torque. So selection of this gear ratio is very tricky and is challenging for every motor design. So there are very simple formula and the calculation based on theory, and that theory has to be implemented practically at hardware level and the hardware implementation. There will be always deviation from the theoretical modeling and so on and so forth. So that hardware implementation is always tough and it takes time. So gear ratio, you have to pay attention so that you achieve all those required electric motor parameters at different gradients. Otherwise, if your electric motor could achieve the parameters at 0 gradient, if it fails to achieve at 10, then your electric motor may not be suitable for hill climbing or maybe some cities where you have the combination of up and down roads. So there you will face problem. That is where we have to consider all these factors while designing a new electric motor for the electric vehicle. Then why we need gear ratio, I will show you a video also to make you understand better. Then next one is the motor cooling selection. So one has to consider what kind of cooling is required for your electric motor, whether we should go for the water cool or we should go for the air cooled version. For the smaller vehicles like two-wheeler, three-wheeler, and the smaller passenger cars, so air cool will be sufficient. And for bigger vehicles like SUV and mini trucks and buses, electric buses, then we need the water cool or liquid cool electric motors and the drive system. And battery selection and sizing, one of the very important factors that we should consider while designing electric vehicle, not electric motor, complete electric vehicle, which category that vehicle belongs, and those things has to be considered. And based on that, we have to select the suitable the battery and its sizing and the capacity and so on and so forth, ampere hour, how many voltage we require. And right now, as per the automotive industry standard that we call it AIS standard, so 48 volt is required for all two-wheeler and three-wheelers, and for the mini van and the passenger cars, it can be either 48, 72, or 96 volt batteries. So right now we are using lithium-ion battery because of the fact that it has the highest energy density with the lighter weight and less size in comparison with the other batteries. So lead acid battery is a gone technology. It is obsolete and the outdated technology for EV, and people are still using lead acid battery for ICE vehicles for starting and other electrical devices for the vehicle. So this battery, I'm not covering it because it is out of my research area also. So before going to next slide, I will come back to the gear ratio and show you a video which will make you more understanding why we need different gear and the gear ratio to achieve the torque requirement for different terrains. Yeah, I think this video is visible. Hello, can somebody confirm me video is visible or not?
Yes, sir. Yes, sir.
Okay.
It is visible,
Simply
sir.
a gearbox has been serving automobiles well for many decades. Today, it's the most popular form of transmission. We'll give a conceptual introduction on the workings of an actual manual transmission with a reverse gear. Is why transmission is required in an automobile. By the engine flows through the transmission before it reaches the drive wheels.
So here, all the drive system is same. Only thing is that for electric vehicle, we replace the engine with the electric motor. Then all other will remain same for this particular vehicle with the rear drive system.
Is to control the speed and torque available to the drive wheels for different driving conditions. Want to climb a hill, you need more torque. By reducing the speed at the transmission, we will be able to achieve higher torque for the same power input. If the torque demand is low, we can increase the transmission speed. Inner workings. Transmissions work on the simple principle of gear ratio. Mechanism is shown here. And output shafts are connected through a counter shaft. This will look like this. By sliding the gears, we can achieve different transmission ratios. More specifically called a sliding mesh transmission. They're good for controlling the speed, but they have an inherent disadvantage.
And here I would like to mention that it is just a demonstration to make you understand. It is not the gear system that we use for an electric vehicle. Electric vehicle, we may either have the single gear system or dual gear system. That's all. We don't have a multi-gear system because of many technical disadvantages and as well as escalated costs. So it is just to demonstrate to you how the power is flow from the input to output shaft and why we need gear. Then how the gear ratio is calculated, just to demonstrate that. So for electric vehicle, either single gear or dual gear. That's it. No multiple gear.
Slide from one gear and engage with another gear. Transmission permanently solves this problem. Gears are always in mesh, but with a major difference. Here, the output gears are loosely connected to the shaft. Synchronizer ring against the cone.
All right, coming back to the slide. So I have just shown you and demonstrated to you how important the gear ratio is for any moving vehicle, either is a IC engine vehicle or electric vehicle. Then we come to the EV performance evaluation. So when we talk about EV performance, then it can be subdivided into two. One can be from the economic performance perspective, and one can be from the dynamic performance perspective. Under the economic performance perspective, we have two subcategories like driving range. So we focus on the driving range. Whatever we do, all the EV performance studies, whatever, we simply focus on the driving range. Increase in driving range is the one of the desired parameter for any vehicle manufacturers as well as for any vehicle model, which will be desirable by the public. So with the single charge, if you are able to travel 1,000 kilometers, it will be fantastic. That's why the economic performance is divided into two. One is the energy consumption study. Then this will give you more insight of the your EV motor design and its performance, second by second performance, as well as all other how your EV is performing, your EV motor is performing on a specific power, then its boundary conditions, then so on and so forth. That I will explain you in the next few slides, that how the energy consumption is studied and analyzed. And from the dynamic performance perspective, we have the acceleration ability and the maximum speed. These are related to the dynamic performance. Then acceleration means how fast you can accelerate and reach 100 km/h speed. Then maximum speed in comparison with the ICE vehicle. So what is the maximum speed? So and then around 120, 150 km/h will be more than enough for Indian roads. Then we come to the drivetrain topology. As I said, told you in the beginning that we have a different combination of e-motor, the configuration, then how the EV motor and the gear system is positioned. Then we can have different drivetrain topology. On the first, the configuration on the top left, you have the EV motor. EM represents EV motor, GV represents gearbox, and D represents the differential. Then EV motor is connected through the clutch to the gearbox and then differential. Then this is basically very similar with the IC engine vehicle. Only thing is that your IC engine is replaced by the electric motor. So you have the clutch, gearbox, and differential. And this is not so popular because of the presence of clutch, extra cost, and the loss of friction loss. Then we have the second configuration. We have the EV configuration without clutch, but with a fixed gear. Then we have electric motor, and it is connected to a fixed gear. It could be a single gear system or a dual gear system. Then which is connected again to the differential, and that is how it works. It is this configuration is used in Tesla Model S. Then the third one is the transmissionless drivetrain. Here we don't have any gear system or transmission, and your electric motor is directly connected to your differential. One of the typical example is your electric rickshaw. If you observe the electric rickshaw on the back side, you will notice that your electric motor is directly connected to the differential of the wheel axle. And the fourth one is the cascaded motors drivetrain. Here we are using dual electric motors with a common axle. So this will be more powerful, and it is a rear drive system. And this is just for study. I think in Tesla model Roadster, I think they used dual electric motor. So due to the presence of extra electric motor and the hardware, so the cost will be more in this case. And the fifth one is the in-wheel motor with reduction gear. Here we have a dual electric motor without common axle. Means your individual electric motor is connected to the wheel through a reduction gear. You can see. So in such case, your the control algorithm is more complex, and the overall complexity increase. And the last one, we have the in-wheel direct drive system. Basically here we are using the hub motors. Your wheel rim itself is the electric motor. So here again, because of the presence of multiple electric motor, your control algorithm and the controller has a very complex algorithm. So these are the different drivetrain topology that we can have in an electric vehicle. Then going little bit in detail, how the gear ratio and how the transmission works, how your electric motor torque is transferred to the wheels, or then through your drivetrain, through the gear system. So that from the video you can understand how your input shaft and output shaft is connected through the gear system, then how your the input torque is transferred to the output torque to the wheel through the drivetrain system. So this slide represents the simple pictorial diagram from the electric motor. The torque, which is represented by the Tm, is transferred to the wheel torque on individual wheels. Wheel torque right and wheel torque left. So the calculation is very simple. If you look at the Tm, when you have a Tm, then how you calculate the Tg, torque at the gear. Then Tg is nothing but K0 into Tm. Means K0 is the gear ratio. So likewise, when you want to calculate the torque at the differential, then torque D is nothing but your this K1 and the torque Tg. Tg is the torque at the gear. So that is how you get the torque at the differential. Again, torque at differential is divided into two torques. Because of the presence of two wheels on the left and right, you have the torque on the right wheel and the left wheel. Again, your force, which is you are able to move the vehicle because of the force on the wheel on the surface, the traction, the force. Then your force is calculated from the torque. The calculation, you can use the simple equation and calculate. These are the theoretical you can calculation, and you can do the modeling using some MATLAB or other suitable software. You can calculate that for a specific electric motor, given a torque, how that electric motor torque is transferred through the single gear or dual gear system to the your differential torque, then to the wheel, and then you can calculate the force acting on its wheel. These are the method that how you can calculate and evaluate virtually your electric vehicle using some soft tools before going for the hardware implementation. So due to many advantages, mechanical simplicity, so we simply use the single speed drivetrain system, and because it is easier to minimize the cost and the volume, energy loss, and drivetrain mass. Because once you use the multiple gear, there will be an increase in weight, increase in material use, gear, and then increase in cost, so on and so forth. So now we come to the two case studies that we have done in our campus. So we have converted two in-use Maruti car. One is the Maruti 800 and Maruti Zen into electric vehicle. So now we are running on the electric mode, these two vehicles. There is no engine, no fuel consumption, nothing. So it is done as per the GSR gazetted notification from the government, and it is done as per the automotive industry standard AIS 123 part 3. And this legislation is a new one, and you can have it from internet. You can download and you can have a look. And this GSR was basically drafted by us only based on our research study. And we have done this research study for last 4 or 5 years. Based on our research study, then we have proposed to the government that why to waste all the in-use vehicle. It will be huge loss of revenue and huge loss of resources for the country. That's why we done research, and based on our research, we proposed the draft. Then government accepted after consulting all the testing agencies and the other stakeholders. So I was very lucky to have a test ride along with our ministry, Minister Dr. Harshvardhan that time. And this on the top, we have the topology, complete vehicle drivetrain topology that we use in this electric vehicle. The top one is the complete vehicle drivetrain system for our EV1 and EV2. And for experimental setup, these are the pictorial representation of our experimental setup, how we conducted our research study after the electric conversion of the two ICE vehicles into electric operation. So in the chassis dynamometer, we use the power analyzer to capture all the electrical parameters and measure it and analyze all the electrical parameters, voltage, current, then the phase angle, then harmonics, so on and so forth for that particular EV motor on the following the drive cycle. So after this slide, I will show you a real laboratory test through a video which I captured myself, the video. Then you will see how an electric vehicle is tested on a standard chassis dynamometer following a driving cycle. Then we do the laboratory tests. Then after laboratory tests, standard laboratory lab tests, then we go for a real world testing on road, on traffic. Then we compare the two results on some selected vehicle parameters. Then we compare it, check it, and we use different equipments like global positioning system, GPS data logger, then so on and so forth that I will show you at the end of the presentation. And these are the some tests instrumentation that we use as a part of the methodology that we followed. And we have used some sensors, current sensors, along with the current clamp, and to measure your current flow and the current consumption. Then we use the different power analyzer from the Yokogawa WT5000, very efficient and a very expensive power analyzer. And we have a portable power analyzer. And we have NI DAC system with the four slots, chassis having 4 slots. Then we use the GPS data logger for the on-road data collection and data generation. Then we have used the digital vehicle weighman system to check the vehicle weight distribution after the installation of your all EV subsystem inside the vehicle. After integration, we need to check the proper weight distribution, because proper weight distribution is very important from the safety and the stability point of view. So we need to check the new center of gravity before and after the electric conversion. So the center of gravity should not be deviated too much from the original center of gravity. Then the methodology, the selection, sizing, then cost down tests before conversion to estimate the F0, F1, and F2. F0, F1, F2 is they are the parameter for a vehicle moving on a road. These are the force acting on a moving vehicle. So this F1, F0, F1, F2, I will explain you next slide. What are these parameters? And then we have the selection drive cycle, then test setup on chassis dynamometer, testing for the tailpipe emission before the conversion. We need to check the original IC engine was emitting how much emission, as well as it was consuming how much fuel. Those parameters we need to determine. That's why before the electric conversion, we mounted a vehicle on a chassis dynamometer using different equipments. We measured the vehicle emissions as well as the fuel consumption. Then after the removal of the IC engine and its related parts, all the IC engine, exhaust pipe, everything which is related to the engine we have removed. Then we install all the electrical subsystem inside the vehicle, integrate it, and then do all the other scientific adjustment and study. Then we mounted the vehicle on the chassis dynamometer and run operated the vehicle on the same cycle, so that we compare before and after the electric conversion. And then road load simulation test is what we have done it on the chassis dynamometer. These are some summary of how we have done it. It is a very lengthy procedure, so I just explain in a very short, briefly. So maybe at the end of the presentation, when we interact, you can ask me questions if you have any doubt. So what is the F0, F1, and F2, F1? So these are the forces acting on a moving vehicle. So F0 is nothing but your traction force. Here you can see your rolling resistance having on the surface and your wheel in between that. And we have the F1 in the value equivalent to the losses related to chassis dynamometer. F2 is nothing but the coefficient of aerodynamic force that you experience on road. For example, you drive a bicycle or road, you face some sort of force against the wind that you are experiencing the aerodynamic. Then these are the how the vehicle parameters are calculated. This alpha is nothing but your gradient. When alpha becomes 0, then this vehicle will be running on a flat surface. When alpha is 5, your gradient angle is 5, 10, 17, 22 as per the standard. Then mechanical torque, then energy consumption, how it is calculated. So these are the equation, and the vehicle is operated on chassis dynamometer, and all the vehicle parameter second by second data are recorded. Then we do the post-process analysis, and the energy consumption is done as per the automotive industry standard 039 AIS 39. So we follow AIS 39 for the energy consumption. Then calculation is given here. This AIS 39 is already available in the public domain in the internet. You can download and have a look how the energy consumption is calculated for an electric vehicle. So we have other homologation requirement as per the central motor vehicle rules. So CMBR homologation requirement, we follow the AIS standard 38, 39, 40, 41. And for our work electric conversion, we follow AIS 123 part 3. So why I'm saying these standards? Because all the researchers and all the people working and associated with electric vehicle should be aligned with the standard and the objective of the government, so that we are all aligned to a main cause and a main objective of the country. So that's why we need to follow all this standard and scheme, so that everybody, all the dots are connected and aligned to a country's objective, the larger objective. So that no one who are working in the this area is not deviated from the main cause. It is properly, you can say, aligned and directed towards the larger objective of the country, and that's why all we can be connected, and we can have a common understanding language and common platform where we can communicate each other. That's why that is why I'm just mentioning these standards. And I will share you how we do the vehicle testing inside our laboratory on a chassis dynamometer following a standard test cycle. Here, this is this computer, we call it driver's aid. So this computer will guide the driver by showing the speed profile of the Indian driving cycle. So this is the speed profile of the Indian driving cycle, and the driver has to accelerate, deaccelerate, apply brake just to follow the speed profile of this cycle. That is how we do the test in our laboratory on a chassis dynamometer. And you can see here that all the electrical parameters are tapped and inside a bonnet. So we are measuring simultaneously when the vehicle is driven on a chassis dynamometer following the Indian driving cycle. So for the drive cycle analysis, such tests are required. And then we will compare the all electrical parameters along with the drive cycle. Now coming to the drive cycle analysis. So now we have, assuming that we have performed the laboratory test using the Indian driving cycle IDC. Then now we are coming to the analysis part. Basically a drive cycle or any driving cycle is characterized by 4 drive modes. That is basically the idle, and then acceleration, then deacceleration, and cruising modes. So these 4 drive modes represents a driving cycle, any standard driving cycle. Then we need to see the percentage of cruising mode, acceleration mode, and then deceleration mode, then idling. Based on this, we can segregate all the electrical parameters and we can analyze their boundary conditions and which parameter is behaving, how in which drive mode, so on and so forth. This is how we do the drive cycle analysis, and it is for one of the cycles, and we have so many other driving cycles like Japanese driving cycle, European driving cycles, American driving cycle. In India, we have two driving cycles. One is the MIDC, we call it Modified Indian Driving Cycle. Another one is the older version, just IDC, Indian Driving Cycle. So and so forth. We have a new driving cycle coming up, WLTC. So worldwide light vehicle test cycle, that WLTC is coming up. So these are required at vehicle level. So then we have developed one computer program for the segregation of the test data with respect to the 4 drive modes. Then we can segregate how much energy consumption in which drive mode and what was the maximum current drawn in this particular drive mode. From those parameters, you can decide that this is the maximum current in this drive mode. Then those data are required for the EV motor designers and those engineers working for the batteries and the BMS system, so on and so forth. And these are the 3 test cycles that we use in our lab. One is, as I said, Indian driving cycle, all one, having maximum speed of 42 km per hour. And it basically used for the 2-wheeler and 3-wheeler testing. And the second one is the Modified Indian Driving Cycle, MIDC, and it has 2 phases, phase 1 and phase 2. Phase 1 represents the city drive condition, and phase 2 represents the highway driving condition, and having maximum speed of 90 km per hour. And phase 1 have around I think 50 km per hour speed range. And the third cycle is the WLTC class 2 cycle. Here we have 3 phase, low, medium, and the high. Low represents the city driving condition, and medium represents the suburban driving condition, and the high represents the highway driving condition. So these are the 3 test cycles that we are using right now in our lab, and it is adopted and used all across India in all the automotive industries, as well as testing agencies like ARI and ICAT in Manesar. And these are the some small the analysis, how we do the analysis that I just tell you. For example, we have conducted steady speed tests like constant speed tests. And you can see on the graph that these are the 20, 40, and 60 speed we have conducted. Then corresponding electrical parameter, you can draw the graph and you can do the analysis. Then maximum, minimum, average, so on and so forth. Statistical analysis also you can do it. So this is one of the tests that we have done it, constant speed tests. So from here you can see the range of load current required to move the vehicle from standstill condition, for example, like a traffic stop and go condition. Once the vehicle is stopped, and then when the green light comes, then you start moving the vehicle. At that time, at that condition, what is your the range of load and the other electrical parameters? Those things are required while designing. So these are the some the test analysis that I would like to share you. And like that we have for the MIDC. So all other EV parameters you map, you draw the graph along with the cycle, then you can analyze all the electrical parameters. So then again you have the drive cycle analysis. You do the segregation with the very in-depth analysis. Then you segregate based on the drive modes, idling, how much percentage input power, then energy consumption in terms of watt-hour per kilometer, during acceleration, how much those values, and during deceleration mode, how much those values, during cruising, high speed, then how much those values for all the 3 cycles. That is how we segregate the data and then analyze. and that determine all the boundary conditions. And then after the lab test, we take the vehicle on road after having all the test equipments installed in the vehicle. Then same thing, we measure it, all electrical parameters and the GPS parameters like your position, length, longitude, latitude, then vehicle speed, so on and so forth. Then you can easily do the post-processing analysis, and even you can do the mapping. Mapping depends on the GPS location. Then like that you can drive, depends on your selection of the route in a particular city. And the selection of the route is very important for every city. We have a tier 1 and tier 2 and tier 3 city. So the Dehradun city where I am, it belongs to the tier 2 Indian city. So for tier 2, the traffic pattern and the road or classification of roads are different. For tier 1 city, the classification is different. For tier 3, classification is different, so on and so forth. Depends on that, you have to select the routes. So selection of routes is another exercise. That, for example, which route is having a low traffic, then medium, then congested route, like that. We have done this exercise for Dehradun. We have selected 3 routes which represents low traffic, medium traffic, and heavy traffic. So that you can do it in your city where you are. Then analyze for the commercial EV also, like Tata Nexon, Tata Tigor, and so on and so forth. And the then like that you can have all other electrical parameters map along with the GPS parameter. Then one last thing, one important finding that I would like to share you that in the congested, so you can see in the last graph, the portion encircled by this green. So it illustrates the rapid increase in speed and current power, indicating the vehicle's movement from a standstill condition. For example, this vehicle was stopping at a traffic point, then it suddenly start moving it, then you recorded a speed as well as other electrical parameter of the vehicle. Then these are the conditions which represents your start-stop at traffic points. These are the parameters that you require to capture and to compare it, the boundary conditions you recorded in the laboratory. So these are the important parameters for the designers. So like that you can do the segregation of all other parameters, and you can plot different graphs like bar chart, then pie chart, and so on and so forth, and a waterfall diagram for other specific parameters like energy consumption or power consumption or torque. Then we can have the GPS mapping. The real world energy consumption along the GPS path, we can map it. You can, from this graph, you can see that which area was having more energy consumption. The bigger dots represents the more energy consumption for that particular route. So you can identify that, okay, this area at this turn, at this corner, at this traffic point, the energy consumption was very much more than other areas. Though, and then you can say from this bus stand to this bus stand, the energy consumption was more. So these are some directions of our research. And you can say so that we can align and find more research areas so that we benefit and our public benefits, our EV manufacturers and researchers benefits each other. Then these are the percentage calculations, so on and so forth. There are so many things. So in conclusion, so time is running out. So before 11:30, I want to finish it, and we can go for discussion. So after the vehicle electrification, what are the benefits before and after? You can see on the table. Before the electrification, we have the vehicle pollutants in terms of grams per kilometer. Hydrocarbon, IC stands for hydrocarbon, 1 point, and the NOx, nitrogen oxides, carbon monoxide, carbon dioxide, this much grams per kilometer. You can imagine the carbon dioxide and monoxide grams per kilometer. If this vehicle, the same vehicle operates for another 10,000 kilometers, then imagine how much pollutant this vehicle is throwing into the air and into the environment. So these are the certain parameters, some vehicle parameters before the electric conversion. Then after the electric conversion, we have the zero vehicle emissions, no more pollutants from the vehicle, then only electric consumption for the recharging of the battery, and so on and so forth. And the conclusion, then, so it is just a repetition of what I said. So we can have the statistical analysis for all the parameters, then for every driving cycle, and for every traffic route that we selected, and we have driven the vehicle for low traffic, medium traffic, and heavy traffic. Like that, we can have different analysis and different test results from different research perspective. And this one, I would like to just say that only electric and the hydrogen fuel cell electric vehicles have the potential to achieve the magnitude of life cycle GHG, greenhouse gas emissions reduction needed to meet the Paris Agreement goals. To align with the Paris Agreement targets, the registration of new combustion engine vehicles should be phased out by 2030 to 2035 timeframe. So it is reported by the ICCT report, July 2021. It is available on public domain, and one of the graphs that was found in that report, I just represent you here. So this graph represents that life cycle GHG emission of average medium-sized gasoline internal combustion engine versus battery power electric vehicle registered in Europe, United States, China, and India in 2021, and the projected to be registered in 2030. You can see here that BEV, battery electric vehicle, is having lesser GHG emissions in comparison with the ICE vehicles. These are the all ICE vehicles on the higher graph. That means on the y-axis we have the life cycle GHG emissions, the carbon dioxide equivalent per kilometer. So that means IC engine vehicle will be always having the higher carbon equivalent per kilometer. Whatever the mechanical engineers may be saying at any platform or wherever they are. So this is the UN supported ICCT report, International Council of Clean Transportation, something like that, ICCT. So whatever they say, because they have to survive, no, among electrical engineers with the incoming of electrical vehicles. Otherwise, it is that's why they will cook up all sort of stories. And they actually vehicle, you take any vehicle, either it is IC engine or electric vehicle, it is a product of multidisciplinary. Mechanical engineers will be required, electrical engineers will be required, electronics will be required, and computer engineers will be required. This they should accept actually. Now the IC engine era is becoming obsolete. So mechanical engineers will be going back to the back bench, and electrical and electronic engineers will be coming to the front bench. It's not that they will be out of the room. They will be in the room in the team only, but their importance is interesting. This is now they are not able to digest. I'm sorry to say that. I have seen in many platforms. Now coming to this next slide, we have done some experiments using supercapacitors for EV application. So we have procured some supercapacitors from Maxwell from US. Then we have done the hardware implementation and the checked physically the the modeling in the computer modeling and simulation. We have done a real world application and experiment and tested it how they will be suiting to EV application. So these are some pictorial representation of our experiment conducted for individual supercapacitor cell. Then we met ourselves the supercapacitor bank with the series parallel combination. Then these are some experiment graphs we got it. Then this is our major test facilities that we have in our laboratory. We have two sessions dynamometer. One is for car and the trucks, and one is for two-wheeler and three-wheelers. And these other equipments are shown for the IC engine vehicles, not for EV. EV, we need only sessions dynamometer and a power analyzer and some data acquisition system. That's all. We don't need all this CVS system, emission analyzer, and so on and so forth. We don't need huge equipments. And we have, as I said, we have GPS system, then power analyzer, then we have NI dark system with the lab view, and we have onboard emission analyzer, which this equipment will measure the vehicle emissions for any ICE vehicle on road, on traffic. So, and we have some IC programmer for embedded system technology. Then we can program, we can do coding for our own purpose, for our own application. Then we can deploy that board onto our application and to do the job that we define. And some comparison of the currently available two-wheeler EVs. You can see the Ola two-wheeler is coming up with a very huge impact, which will cost you around 1 lakh plus minus 10,000. Then another two-wheeler company at her, so they have a different model with the 1.5 lakhs range. And these are some parameters, some comparison. Then Bajaj, you have Chetak. The old Chetak is coming with a new version. So it can be an old name and new, you can say old wine and new bottle. Then TVS, we have iQube. These are the Indian models which are will be available very shortly in Indian market. You will be seeing it, and Ather already in Indian market, already on road. So these are a replacement of all that IC engine mopeds. And the comparison of presently available four-wheel electric vehicles, you have MG JS EV, then Hyundai Kona, Tata Nexon EV, then we have newly launched Tata Tigor. These are the powertrain comparison of these three, and these are the price comparison of these three EVs. Then comparison from the global perspective, then we have Indian company Mahindra, Reva E20 Plus, we have Mahindra XUV 300, the EV version, then Tata Tiago, then Nexon, and then we have from the global market, we have Tesla Motors, already came to in India and already open an office in Bangalore. They are doing some survey, intensive survey, and there they will be launching a model in India. And Volkswagen and a Nissan Leaf is one of the very successful EV. So these are some comparison with range, maximum speed, EV motor power, and then battery power. So future scenario. So the mobility for future, it will be a mixture of IC engine plus EV plus the fuel cell. Fuel cell will take a lot of time because of the level of research now. The EV, the mixture of EV and IC engine will represent future mobility. So EV definitely will take over the IC engine over a period of time, but it will take time. So people has to accept and their mindset has to change and adapt to the new technology. So I will just quickly show you these videos.
The ultimate implementation would actually see you using a smartphone, having an app, ordering a volocopter to the next voloport near you. The volocopter will come autonomously, pick you up, and get to your destination.
Oh, we are quite happy to be in Berlin, Germany's capital city, at the BMT, the Berlin Motorcycle Days, which is that motorcycle exhibition in Berlin. And we are very happy here to present our e-rocket to more than 40,000 visitors in only 2.5 days.
What is so special about the e-rocket? Can you describe?
Cycle, which is operated with pedals only. The throttle on the handlebar is not existing. You pedal fast, you drive fast, you pedal slow, you have a slowly ride, you stop pedaling, you stop the motorcycle. Everybody can do it. You need a motorcycle license because it's quite fast. It goes up to 90 kilometers per hour top speed. It has a range of 120 kilometers before you even have to go to your first charging. It's a very fascinating motorcycle, and I can promise you it has the most fun factor in riding from all the two-wheelers on the globe.
Say it's a human hybrid. What does it mean?
The human hybrid means for us, the rider is the center of the universe, of its riding universe, because with the pedaling, you are in a constant exchange with your bicycle, with your motorcycle, excuse me. It's a very, very important point that if you don't pedal, you don't move. If you pedal, you move. But you manage also with the speed of your pedaling, how fast or not fast you want to move. That has been proven by a ton of test riders.
Crawl sideways like a crab. Look at that. Isn't that insane? This is the Mercedes Vision AVTR. See it on the roads for the very first time. There are so many cool features about this car, but look at this. It can drive sideways by about 30 degrees. I want it.
Okay, thank you very much for your kind attention and patient attention. Now the forum is open to all, and over to you, Dr. Kundan. Thank you very much.
Thank you so much, sir, for your very nice and informative presentation. Really, we have enjoyed your lecture, enjoyed your informative talk. I hope participants can also face their views. And also now question answer session is open. So I request all the participants kindly interact with the speaker. If you have any doubts, if you have anything in your mind regarding your EV and all. So if you are present, then you may ask directly, or else we will read your chat box if you have sent some questions to your chat box. But if you are present, then directly you can interact. I am giving permission, okay, already permission is given to attendees to unmute yourself. So either you can unmute yourself and you can ask your question directly.
Hello, sir.
Thank you.
Yeah,
Hello, sir. I'm audible.
Yes,
yeah, I can hear you. Yes.
Yeah, good morning, sir. Very nice session, sir. Coming to that last topic we have touched about, that super capacitors, connecting them in series and parallel combination. In that, what we have done actually, what the outcome we have got in that by researching on that. Actually, as per my knowledge, it gives more power, whereas battery gives more energy. So by how you use that one in combination to that battery, what you have tested actually? Can you say something, sir?
Yeah, thank you for your question. And yeah, you have rightly said, supercapacitors are for power, for instant power that you need for say instant torque, like high acceleration, or maybe for starting of the vehicle, you can use the supercapacitor. And yes, the battery is for energy. Yeah, and the combination of these two are called HESS, Hybrid Energy Storage System. For that, you need different power electronics, different algorithm for the different operation, depends on your operating condition. So that is what we are working on, the development, the control algorithm, how and when your supercapacitors will be assisting your battery. Did I answer your question? But at the moment we can't share the technical data with you.
Okay, sir. Okay. And one more thing, while making that conventional ICE, converting that one into EV,
Yes.
you said that the maximum speed here we can achieve around 120 for ICE, whereas when it comes to that converted vehicle, it's around 64.
Yes, yes. That is for vehicle is
kilometers. 64.
experimental vehicle. So it is depends on your selection. Combination you have to see it. For example, first of all, you have to decide that for which category of vehicle, which segment you are designing, whether it's L1 category, L2, L3, L4, L5, or whether it is for M1 or N category or A category. Those categorization of vehicles, you have to be well aware of those categorization. Then only you have to decide that your vehicle will be belonging to which category and the segment. Then as per your decision, then you have to decide your EV motor, then maximum permissible speed of that segment, and so on and so forth.
In dynamometer testing, you have shown in the video, is it a front wheel drive or rear wheel drive?
Yeah, it is a front wheel drive.
Okay.
Yeah, all these combinations are you have to see at the beginning. For example, like whether it should be a rear wheel drive or front wheel drive, accordingly, one is to design. What I'm saying is from the vehicle level point of view, not at a subsystem. Subsystem, you don't need to consider all these things. But at a vehicle level, you have to see that front wheel drive or rear wheel drive. And for three-wheeler, of course, it is a rear wheel drive always. And for two-wheeler also, it is a rear wheel drive. But for the passenger four-wheelers, then you have to decide. Then the number of motor to be used, single motor, dual motor. Then the number of energy sources you have to use, whether only the battery or a combination of battery and a supercapacitor. Those in that supercapacitor you can add on later on once your vehicle is started operation and then you have demonstrated. Then these are the areas that we can work on all the people who are working in EV areas. There are so many scope actually.
How you have created gradients, sir? How you have estimated the gradient? How in the laboratory? How you have created?
Yeah, that you can simulate using the chassis dynamometer. That's why the chassis dynamometer is the device. I think I would like to request and recommend you may visit any of the testing agencies or any automotive industry where chassis dynamometer is there. So then chassis dynamometer, it is a simulation of your road test and road operation, on-road operation. Whatever you are doing, the activities when you operate a vehicle, like applying a brake, then acceleration, deceleration, those activities you can imitate on the chassis dynamometer.
Yeah, and for coming to ICs, 15 years old vehicles need to be scrapped now. So that is the government rule. Same, suppose if the engine is outdated beyond 15 years, can the same vehicle be retrofitted, sir? What is the government policy about it?
Yes, it is GSR 167E. No, you may go through that. You no need to wait for 15 years old. When your vehicle is 14 years old, then you convert it to electric vehicle and go for re-registration with the green number plate. Provided that your kit has to be type approved or certified by government agencies.
what is the expected budget to convert that ICE into that EV?
Right now, some kits are available in India, the Indian make kits. I'm not talking about the imported kits. We are not talking, and we are not emphasizing on the imported kits. We are working for the import substitution. So there is one Indian company, they have already launched one kit for a passenger car. I think passenger car for sedan, Honda City and so on and so forth. The kit will be around 5 lakhs because they are using imported subsystem. That's why the cost is. If you are using the Indian make components, then cost will be reduced.
Sir, we have shown Maruti model, no sir? For Maruti model, 5 lakhs, around 5 lakhs.
No.
Converting.
I'm not talking about Maruti. I'm talking about the commercially available kit.
Okay. Is it for micro vehicle, micro car, or sedan type car?
Sedan.
Bigger size.
Sedan class.
Thank you very much, sir. Thanks for the interaction.
Thank you.
Nice session. Thank you.
Yeah. Any other questions?
Any other questions, sir? We can see one question from Vaibhav. Are you there? You may ask directly. Or shall I read? Okay, I'm reading this question, sir. Okay. Which question is, if AC current leakage occurs inside the EV, then is there electric shock inside or outside touching? And if it happens, then is there be any residual leakage current testing mechanism? This is the question, sir.
No, there will be no leakage of current. There should not be. It has to be ensured, and it should be like IP ingress protection is there. No, IP 67 compliance and 65 compliance are there. When I say AIS standard, all those standards will come into the picture. Then when you go for the type approval certification, all those parameters are tested, checked, double checked, and all the subsystems, then your insulation, type of insulation, those things has to be compliant as per the standard. So there is no question and no current leakage, no question of current leakage and no question of residual. Otherwise, your vehicle itself will fail during the type approval testing. You will not be able to launch in the market.
Thank you, sir. Any other questions from audience side? Okay, sir. I have just a generic question.
Hello, sir.
Yeah, please. Go ahead, please.
Sir, Indian driving cycle, normal Indian driving cycle, and modified Indian driving cycle, and the last one you mentioned. Can you please?
WLTC.
What is that one, sir?
WLTC is the worldwide light vehicle transient cycle, test cycle.
Should we follow that in India? Should we follow?
WL procedure is there, TP is there, test procedure is there, TC means test cycle. So it will come up in India because when Euro 6 comes, that Euro 6, your Bharat stage 6. So it is a very long story, and it will be coming up for the IC engine as well. There is a talk already in the government that RDE, real driving emissions, will be coming up in India. All the IC engine vehicles which compliant with the BS6 norms then has to comply with the RDE norms. When RDE norms is compliant, then this WLTC cycle will be compulsory for the new vehicles. They have to be tested using this cycle.
Actually, Indian government announced 1/3 of the diesel vehicles has to be banned by 2030. Can we expect any extension of this because of 2 years of Corona, sir?
Yeah, it can be. It can happen. Anything can happen in future. But anyway, there has to be some vision and the goal setting, no? Then all the research can be aligned to that goal, and we can work together so that we shape our country's money, the exchequer money going out of the country for importing crude oil. You know, crude oil out of 100 liter, India is producing only 20 liter. 80 liter we are importing from outside. Can you imagine how much money is going out of India? So the 10% first target is to reduce the 10%. That means out of 100 liter, India manage 30 liter and then import only 70 instead of 80 liters. It is a huge saving. Those the saved money, the money can be diverted to other useful things for the public.
Any more question? Okay, sir, I was discussing about that. Okay, it's a very informative session, and I've seen like you have done wonderful things. Even I am following your work. You have done your PhD from Guwahati under Praveen sir.
Thank you.
So I am very close to him. For this session, for this FDP, I have requested many times. Maybe his busy schedule, he has not given time. I understood his very busy schedule. So anyway, thank you so much, sir. And one generic question I have, like, okay, if some as a point of participants, okay, as per my coordinator or my NIT Manipur point of view, I will be discussing later on. But as per the point of participants, view of participants, if someone wants to collaborate with you or someone wants to work with you, with your scholars, if you have there, something like that. So what are the scopes to work and how to collaborate with your organization as a participants from all over the India? If they want or they have something in their minds, how they will proceed.
Yeah, thank you, Dr. Kundan, for that such a nice question. And it is always possible. We being the government research laboratory, it is always possible. It has been going on. It was going on. It's been going on with other academic institutes like IITs. We have a lot of MOUs with IITs and some NITs. It is always possible through a MOU, and we have to define the scope of collaboration, including the academic collaboration as well as the research collaboration and the students exchange program, whatever. It is already always possible. We are already having MOU with many other universities and institutes, including some private universities also. So it is always possible, and you are most welcome. Your MTech students are most welcome to do their 1 year, you can say 1 year, what is that? 1 year project, no?
MTech, yes, yes. Second year MTech project, yeah.
And the BTech, we are a little reluctant because only 6 months is very too less.
Yes, sir.
Nothing can be done in 6 months, and we can't get much out of the student in the 6 months. So we encourage you to send your MTech students. Maybe we can co-guide your PhD students also. No problem. It's under MOU. It is always welcome. You are also government organization. We are also government organization. Only thing is that we have to find a common point, common join, then where we can connect each other.
Yes, yes, sir.
Always possible. It is already there with other IITs.
Yes, that I assure you, sir. Very soon I will talk to my head of the institute, director, sir, regarding this MOU with Dehradun, with your institute. That I assure you, sir. And
the advantage is, Dr. Kundan, I would like to share you, since you started this. IIP is one of the government and panel testing agency as per the Central Motor Vehicle Rule 126. So like ARI in Pune, the testing agency in India for automotive industry, and the ICAT in Manesar, these two testing agencies are doing the only certification for all the new vehicles in India. We also do certification for very selected models from Tata Motors and the Mahindra. And we don't do for all the automotive companies and all the vehicle range. We only do selective, which we can do it. Because our laboratory is something like, it is a bridge between two industries. One is the oil industry and another is the automotive industry. So whatever oil industry does, it has to be used in automotive now. So it has to be connect somewhere. The one has to communicate each other. What is the requirement from the automotive side and what is the requirement from the oil industries? So we are the bridge between these two industries. And then whatever any new fuel comes up, like the blending, 20% ethanol blending, those fuels, it has to be tested in the IC engine. Until and unless you test the fuel, whatever the new fuel, you don't know the performance and the desirable, fuel economy, then emissions from the compliance point of view. You never know it without testing and without applying onto the real product. That's why our lab comes into that. That's why we are into the applied area. We are into the vehicle side. We have other colleagues from the chemical engineering and chemistry. They are on to the fuel side. They give us new fuels. We get tested it on the IC engine as well as vehicle. And I am from the alternative mobility, electric vehicle. And because electric vehicle is moving in a very fast, and it is supported by government with so many schemes and programs with multi-crore programs, then we have to align with the change of scenario as well as change of the technology. Otherwise, we will be left behind. Like Nokia is now nowhere. Nokia mobile was the one of the number one a decade ago. Now Nokia is gone because they could not adapt with the change of the Android OS. So they could not adapt to the change. They did not accept the change. Whatever happened, but Nokia is gone out of the market now. That's why we have to align with the change of the technology and the change in the scenario. That's why I started this electric vehicle area around few years ago. So then I started doing my PhD. It is a part of all those things.
Thank you, sir.
And we are being part of the BIS, Bureau of Indian Standard and Automotive Industry Standard. We know what are the standards coming up, what are the standards information. And there are so many standards they are in making now. So we always do the meeting and on so and so forth. So there is going to be always amendment in the all laws and all legislation. Amendment is required from time to time. Otherwise, we cannot keep on wearing the same clothes for next 10 years.
Yes, sir. Yes, sir.
Like that.
Yes,
So we need some change.
yes, sir. Yes, sir. Thank you, sir. I'm also involved with the EV wireless charging, wire charging. Earlier, during my PhD, I have started analysis with the Nissan Leaf efficiency analysis and all. So after that, just there in PhD, actually I involved from 2013 till now. So I have started my PhD in 2013 and finished in 2016. And a very good professor, life fellow in IEEE. So I have got some idea to start with the EV. Initially, we have worked with little bit with the drivetrain, and now I'm a little bit shifted to charging side, wireless charging and dynamic charging. So one of the scholar who is working at Kalinga Institute of Instrumentation Topology, he is working with me and he's nicely working. So basically, the meaning is that even to do something, hardware experimental things are very much required. So even to test some part of the dynamic charging things, even 5 meters, 10 meters, it costs much. So for the time now, we are trying with the simulation and all. And also, parallelly, I'm trying to set up a hardware platform.
Experimental setup.
Yeah. So I will get
actually, you need some experimental setup, tabletop model, maybe some small motor and dyno, and then so that you can do all this analysis at the downscale level.
Yes.
Small scale level. Then you can think of the scale up models and so on and so forth. But you need tabletop experimental model. We can help you. We know so many suppliers.
Sure.
Who is doing what and from where you can get. We have at least some fair knowledge of, if not all, but we have some fair knowledge of all those suppliers and those things. If you are working the electric motor drive system, including the electric motor, so there is going to be the core unit for any electric vehicle. Electric drive is going to be core. Then there are so many startup companies that we are connecting. They are manufacturing this electric drivetrain system, which Then whoever is interested developing a vehicle, they will purchase this ready-made drivetrain from that company, then integrate into the. That is what the automotive companies are doing. Automotive companies are not manufacturing X, Y, Z, everything. They are not manufacturing it. The overall design of the vehicle belongs to that company. Then they integrate. They get tire from JK Tires, MRF. They get the glass from something that. Then they get from steering from Sona steering. They get the speedometer from Precol. So many companies, so many components they get from all those companies. They integrate into that vehicle and they sell the vehicle. It's not that Maruti manufactures everything. No, Maruti manufactures, for example, Maruti manufactures only the chassis and the overall vehicle design and engine. That's all. Even engine, Tata Motors, if you see, Tata Motors has done a drastic change and a fantastic job. Now they have, for your kind information, they have stopped doing research in IC engine. What they do, they purchase the best IC engine available in market from other companies like Fiat or whatever. Then they integrate into their vehicle. Then you have the Tata Harrier and new Tata Punch, and those vehicles are fantastic. Those vehicles having IC engine from other companies, not from Tata Motors. That's why they are very successful, noiseless. Unlike a Purani Tata Motors, itna ghatna, making noisy engine. No, those days are gone for the Tata Motors. Tata Motors now they have reinvented themselves. They have identified their weakness. They have changed themselves. They have adapted to the changing scenario.
Yes, sir, definitely, sir. So thank you so much.
If there is nothing,
yes, sir, yes,
I
sir.
think we can wrap up.
If there is no questions from audience side, already it's more than 12. So once again, thank you so much, sir, for your very informative talk as well as very nice discussion. So thank you so much once again, sir.
Thank you. Bye.
This is from our side a token of appreciation for you, sir. Thank you so much, sir.
Thank you.
We'll message you or mail you, sir, about other formalities. Thank you so much, sir.
Okay, bye. Take care.
Thank you so much, sir.
Or bye all and take care all.
Yeah, thank you. So thank you so much all the participants for be connected with us. We will start next session at 1:30. So please join on or before 1:30 p.m. That session will be handled by Professor Subrata Banerjee from NIT Durgapur, and he will be delivering modeling and control of switch mode power converters for EV application. So for the time now, we can close the meeting, but okay, meeting will be on. Either you may connect it. So we'll start the session. Our session will resume at 1:30. So please be connected. Please join on or before 1:30.
Thank you, sir. Thank you.
Thank you. Thank you so much. Thank you so much. Already I have shared the link, a feedback link here. You may fill here as well as I'm going to share on the WhatsApp group as well as I will send to your mail. Feedback link for your this 7th session. Thank you so much. Sir, good evening, sir. Your screen is already shared, sir. Banerjee, sir. Sir, you are muted, sir.
Hello, can you
Yes,
hear
sir.
me?
Good. Yes, sir. Yes, sir. Good evening, sir.
Good evening.
Yes, sir. Yes, sir. How are you, sir? Now your health is okay, sir?
Now, okay, taking
Okay.
rest.
Okay, sir. And how's weather, sir? There? How's weather?
Weather is not, weather is all right, but still COVID is there in flat and all this tension is there.
Okay, sir.
COVID also.
Here it's raining now in Manipur.
Oh yeah, there is raining actually.
Morning it is started. So maybe just you have checked, sir. I think you had shared your screen so that you can share, but people are still joining. So maybe you can wait for 5-10
Okay,
minutes.
let us wait for some
Yeah,
time.
you may take rest for 5-10 minutes. Maybe probably we'll start at 13:35 or 40. Okay, sir. 1:35 or 40.
Dr. Kumar,
Yes, sir. Yes, sir.
when Professor Kaushik Basu is coming?
Friday, sir. Friday 1:30 to 3:30.
Okay.
Friday second, like Friday afternoon lecture, they will be taking.
There, I may join at the end, and then we can discuss also some issues after the meeting is over.
Yes.
Possible.
But in the same meeting, participants will be there, no, sir.
If participant left, then
It is,
okay.
no, it is difficult, sir. Actually, after that, some other like testing and all test, I have to conduct the test and all.
Right.
This is not, that will not be good to do any personal meeting. So maybe we can talk, we can request him if he will be available on Monday or Tuesday evening. So in between Saturday, Sunday, we can do our meeting like that. Saturday, Sunday, we can do our interview.
Next Saturday, Sunday, can.
Yes, yes. Till Friday evening onwards, I will be free, sir. Till Friday, I will be busy with this. After that, no. So have you taken your lunch, sir, or you will take after session?
I've taken. I've taken.
Okay, sir. It's a afternoon session, sir. Still, it's a running time. I could understand the FDP in running time, like a semester running in between. It is little bit difficult for the faculty, for the organizer, as well as for the experts also. So I understood this one because everyone is busy with their schedule. So total participants are 130, but sometime 90, 100 something joining. So let's wait, at least 50 should be there. Morning session, it was more than 75 or something like that. So morning session was delivered by one of the principal scientists from CSIR IP Dehradun, sir.
So
he has presented very nicely all the EV and all. He has done his PhD under Professor Praveen Kumar, IT Guwahati.
okay.
So it was very informative.
He's a CSI fellow, no? He came here at CSIR Durgapur also.
He has collaborated something at NIT Rourkela as well, sir. So we'll talk about this in later, sir, over phone to you. So it was very good, and also for the participants also, if they want, any participant wants to collaborate with him or with his team to do some research work or some project work, it is very good platform.
Right.
Because like government institutions, everyone having their facilities like infrastructure, resources, which we cannot avail in most of the private engineering colleges. So in that case, people may collaborate and can avail the experimental facilities. These are the good things. Here weather is everyday changing, sir. Yesterday was very much sunny. Now morning seems cloudy and raining. So, but very pleasant weather, sir. It's good. Okay, sir. After 2 minutes, we'll start, sir. People will be joining. So. This evening we have, sir, one spiritual session from 3:35, 3:45 to 5:45. And his topic is like mind secrets. So he will be delivering.
Biara.
Vera, sir. So if you spare some time, like.
No, I have class after that and then meeting.
Oh, it's a too much seminar.
Very
Like
tight
if you feel free, sir, then actually I have heard his lesson one time. It was really like he's totally involved with the ISKCON, sir. So it is very relaxed session. So
okay.
If you could find time, then at least sometime you may join for your interest, sir. So I think we can start, sir, I guess. We should start. Let's check.
This afternoon time, actually, participants are very.
Yes, sir, this happens sometime.
Much, after taking lunch, they are taking rest actually.
Okay, let's wait for. We just. Then shall I start, sir?
Okay, let us start.
Okay, so once again,
video mode.
very good afternoon. It's okay, sir. I will brief and then you can start. You can share, sir. Okay. Let me brief to you, brief, sir. Then you can start your session. Okay. So thank you all the participants and to you, sir, for accepting my request, and for all the participants to present here for session. Third day, it's 8th session. And once again, warm welcome to all the participants and to you, sir, for this session. Today, we have with us Professor Subrato Banerjee from NIT Durgapur. He's working as a professor and ex-head of the Department of Electrical Engineering, NIT Durgapur, having a total 30 years of professional experience. His field of research interests include modeling and control of converters and inverters, multi-level inverters and modulation techniques, EV charger, electromagnetic aviation, active magnetic bearing, controller design, intelligent control, etc. He has successfully completed few research and consultancy projects. Professor Banerjee has received several academic awards, including 10 numbers of Best Paper Awards and the Tata Law Prize. He has published 190 numbers, or even more than that, research papers in national, international journals and conference records. And he has published 7 book chapters. He has filed 3 Indian patents and 1 patent has been granted in his credit. He has guided 10 numbers of PhD and 25 numbers of MTech students, and many are pursuing their degree under his guidance. He is active as associate editor of IT. He is acting as associate editor of IT Power Electronics UK, and IEEE Access USA, and IEEE Transportation Electrification Community e-newsletter USA. He has chaired and co-chaired several technical sessions in reputed IEEE international conferences like IECP, IECPEE, ICOM, PEDES. He is a regular reviewer for IEEE transaction. So on power electronics, industrial informatics, IT power electronics, etc. He is a fellow of IIT UK, IE India, and IET India. He is a senior member of IEEE and life member of the System Society of India. So once again, welcome you, sir, for this session. Thank you so much to be with us. So now I'm handing over to you. This session I'm handing to you, sir. Thank you so much, sir. Please.
Thank you, Dr. Kundan Kumar, for your nice introduction. I am really thankful to Dr. Kundan Kumar for inviting me as an external faculty member, guest member, to deliver my talk on this topic. on this total FDP program on emerging trends and development in electrical vehicles. Let me share my screen.
Yes, sir. It is visible, sir.
Is it coming?
Yes, sir. Yes, sir. Yes, sir.
So my talk will be on this topic, modeling and control of switch mode power converters, particularly not for only EV applications, but many different applications like solar system, renewable energy systems, battery chargers, and of course EV applications. These are my content, starting from introduction, basic switch mode power converters, then control requirements and techniques, modeling of converters, design and implementation of different closed-loop control of converters, design and implementation of some improved DC-DC converters, bidirectional converters, and finally, multi-level inverters.
Sir, you may make the full screen, sir, if it is okay for you. Full screen, sir.
Where it is
Control,
there?
just you press, sir, Control L.
Control L.
It should come, sir.
It is not coming.
It is not coming, sir. Then it is PDF, no, sir. It is PDF. Then just you. That will not. It just after that, sir. After 75, just after that. After percentage, after that, there is just some page setting type things. After that, sir. There. This one, you click that. No. Fit to Windows one full page. Fit one full page. No, it is not.
Full page is all right.
Control L should come, sir. Okay, let me check in my PDF. Or it was okay, otherwise okay. Let me check in my full screen. It's coming in my case, sir, full screen. Control L, it was okay. Just you click on PDF and then you try to press Control L. No, because you have writing something. Okay, sir, okay, no issue. You carry on with this. Because you are writing. Pad option is also there.
But how do I control this thing sometimes? Okay. Anyway,
okay,
I'm visible now.
Yes, sir. It is visible.
Okay. So my talk from the this content, it is clear that my talk will be mostly based on the converter and control, particularly in the form of closed-loop control, which is required for this type of applications, EV charger and electrical vehicle applications. So whatever be the applications, the basic block diagram of any power electronic system is like this, where power converter input power is fed to any power converter, whether it is maybe the AC to DC converter or DC DC converter or DC to AC converter. The output power, particularly voltage and current, has to be sensed and compared with reference. Then controller will generate the control signal as per the requirement of the load. Now this power converter, sometimes work in linear mode, because earlier we used to have mostly in linear mode of applications where the switch works in the active region. And because of its working in active region, it incurs significant amount of losses. It acts like series transistor, acts like adjustable resistor. In schematic, it is given there. And so in terms of efficiency, it is not more than 30 to 60%. 30 to 60%. Okay. So very poor efficiency. Another disadvantage because of this line frequency transformer, which is used basically for stepping up or stepping down and isolating of secondary side from the primary side. And because of this line frequency transformer, the size and weight of this power supply is large compared to switch mode power converter. But there are several of this circuit because it is very simple. Control is easier. Even a proportional control can do that. You have to sense the output, compare it with reference, and simply proportional control will control this base current of this transistor. So cost of the overall system is less. Here, of course, you have to judiciously select the turns ratio of this transformer so that the output here across this filter capacitor, this is the representation. This kind of voltage will appear across this before filter capacitor. So this VD minimum here, it should be greater than the average voltage output voltage VO, but it should not vary by a large margin. Then what will happen? This voltage VD, this VD minus VO will appear across this transistor, and which will increase the losses further. Okay, so efficiency will further reduced. So another important advantage is it will not produce large EMI, which is generally occur in case of switch mode power converter. You know, in switch mode power converter, this is the schematic representation. This is the, in case of non-isolated type converter, simple buck converter, and this is the isolated form. Okay, here switch is power power device. This transistor, MOSFET or IGBT is used as switch, means either it completely on or completely off, avoiding this to operate in active region. Okay, so it will have higher energy efficiency, and efficiency can be increased from 70% to 90%, and it can still improve by placing these diodes by MOSFET switches and operating as synchronous rectifier mode or in soft switch mode of operation. The efficiency can be increased till beyond 90%, maybe maximum 95 to 97%. Okay, and there are several advantages also. Large power handling capability. You can have, particularly in isolated mode, you may have multiple output, and you have the smaller weight and size because of this high frequency transformer. Okay, but at the same time, the circuit is complex. Here, the EMI problem, EMI, particularly electromagnetic interference that is generated due to the rapid change of voltage or current, and due to that rapid DVDD change, particularly across the switch. And even if we can put the snubber, still you cannot eliminate the EMI to 0%. So you have to take care about the layout, overall layout of the converter circuit. And it may have stability problem, particularly some converter like if it operates in boost or buck boost mode. This is the simple PWM control logic, which has it is a simple though that shows the evolution of the power electronic switch mode converter topology. Here, you know, everyone, basically, fundamentally, this there is a you have to sense the actual output voltage and compare with reference. Then control signal is generated. This control signal has to be compared with a repetitive waveform, either triangular or sawtooth waveform, okay, to generate your PWM pulse. Here the logic is such that if control signal is more than triangular or sawtooth waveform, then high pulse will be generated, then this MOSFET switch will be on, otherwise switch will be off. And as per this circuit connection, you will get the output voltage like this. But there are two difficulties. One is that the pattern of this kind of voltage, that if you see the voltage change, there is a sudden change of voltage from 0 to that high value. And if the input voltage increases up to say 400 volt, then there is a voltage change from 0 to 400 volt. And this kind of voltage, you know, this pattern of voltage may not be suitable for some applications of power supply. for EV charging applications. So there is one issue. Other issue is that majority load, the inductive in nature. Even though the circuit is resistive here, but still it will be not purely resistive. So some kind of stray inductance is there. So when the switch is on, there will be considerable amount of charge. The inductor will store energy, and if you can't provide any path to flow the reactive current, current, then due to that reactive stress, the switch may be damaged. So you have to overcome, and this has been overcome by this standard buck converter. Here LC filter, the second order filter is there at the secondary load side, and this diode is used for providing this path of freewheeling or providing this reactive current flow of this converter. Okay. Now, I am not going to details about the circuit principle because these are all fundamental, but you should know the basic practical aspects, some aspects of selection of inductor capacitor, because in particularly electrical vehicle or battery charging applications, all the converter mostly either it will work either in buck converter mode, stepping up or stepping down, or stepping up, or it will be both in bidirectional mode. So later on we will go for some topology. Here you just see, all of because of its excellent filtering capability, here this ripple current is less, and due to that the selection of this capacitor may not be stringent, because the ESR is one of the important element, equivalent series resistor, for selection of this capacitor. Now due to the decreased amount of ripple current because of the presence of inductor, here delta VO means ripple voltage, which is basically delta I multiplied by the ESR value. So due to that reduced ripple current, you need not have to have lower amount of ESR, okay, for selection of capacitor. So capacitor may not be a costly one. That is one issue. Other thing is that the converter prefers to operate in continuous conduction mode. That is because of this filtering capability. Okay, all of you know that converter may operate either continuous conduction mode or discontinuous conduction mode, but particularly this converter, buck converter, is always preferred to operate in continuous conduction mode. So here this expression, that from the basic fundamental principle, you can always find out this output input relationship, the ripple current expression. And here when you just increase the value of resistance or decrease the load current, at some point of time you will find that the inductor current pattern, it may be on the verge of discontinuity, and at this boundary your output current is balanced by the output voltage by resistance, and that is equal to that ripple current, half of the ripple current, delta I by 2. Okay, and from that you can find out this value of critical inductance, and this to operate this converter in continuous conduction mode, this critical value of inductor LC should be greater than this value, half RT into 1 minus this. This is important while selecting the value of inductor for case of any converter like buck boost and buck boost converter. And this is the waveform where you find that when inductor current is more than the average output current, the amount of stored charge in this area, and that delta Q can be find out from that triangle, half into that area of the triangle, and that is balanced by this T into delta I by 8. So output delta, the capacitor equation from this, it can be formulated like this. Okay, and after getting the value of inductor, you can find the expression of capacitor. Of course, there is another requirement. Your cutoff frequency of the filter, that expression is 1 by twice pi over LC, and this LC you have to replace. This LC you have to replace, And there you find there is a direct relationship with switching frequency and cutoff frequency. But you just keep in mind that cutoff frequency of the filter will be less than at least 20 times of the switching frequency. Cutoff frequency of the filter much less than at least 20 times than the switching frequency. And in the discontinuous conduction mode, this is the pattern, okay, where from you can find out again output input relationship, and you find that here still it will maintain the Bach relationship because D plus delta 1 should be greater than delta. In the Bach converter, as I told you, has a relatively smaller ripple, so closed loop response wise it is better. That way I will see we'll see when we will go for the overall modeling as well as closed loop control of Bach converter. Now this is the boost converter, standard boost converter topology. Here few things are important. You just see the selection of the switch. This switch has to be selected. You just see when the switch is on, the large ingress current will pass through the switch, so it has to be withstand that large amount of current, and that's why the selection of the switch is important. Okay. And here, if this inductor is in series with this supply voltage, okay, and secondary side, due to this presence of this diode, due to the discontinuity in current, high amount of ripple current will be there, and it has to pass through this capacitor, so delta PO will be higher, and to reduce that you have to select the capacitor such that ESR value should always be on the lower side. And to select that of ESR value, your capacitor definitely its value, its price of course will be much larger than the capacitor of Bach type converter for equal power rating. Here output side should always be connected by that load so that the capacitor will be protected. These are all fundamental equations. The average voltage across the inductor over a complete cycle is 0. From that you can find out the output input relationship. And assuming the lossless circuit means if you neglect the losses across the switches, diode drop, if you can neglect, if you consider this inductor is a pure inductor, neglect the capacitor ESR value, then you can find out this output input power is equal to output power. From that you can find out the expression of current, and you can find out this from the current output current expression. The delta BO by BO, the percentage ripple is balanced by D into T divided by RC. So more is the value of capacitor, your ripple voltage will be lesser, okay? And it is also directly proportional to the switching frequency. If switching frequency is more, then also your ripple voltage will be less. So all this will be taken care for selection of capacitor, switching frequency, and the value of inductor. Here the value of inductor again has to be find out from this boundary relationship, and you find here this inductor equation is this one, okay, from the basic boundary equation. Now this boost converter, not like Bach converter, it prefers to operate in discontinuous mode. Later on we will find that if it operates in continuous conduction mode, then there will be one right half plane 0, and due to that the converter system will behave as a non-minimum phase system, and then dynamic response will be poorer, and its bandwidth also will be restricted. So there are many things to overcome this bandwidth, as well as dynamic for enhancement of the dynamic performance. Either you have to improve by the control design, controller side, or you have to modify the topology. So later on we will discuss something about tri-state converter topology or type controller design aspect for eliminating this kind of RHV0 problem. And to operate in discontinuous mode, you see here, this is the relationship. So one thing is important, that inductor value, it should be Okay, that value of RT d1 minus d square. So from this empirical relationship, from the load switching frequency and the operation of duty cycle, operating duty cycle, you can find out the value of inductor for discontinuous mode of operation. So here you see, irrespective of that your delta 1, it will always operate in boosting mode. This converter relatively having more ripple that I have already told you in the current at the output side, and closed loop response is poor because of the presence of RSP0. And in discontinuous mode, the effect of this nonlinear phase has been vanished because there will be no RSP0 on the control to output transfer function. Now, buck boost converter, again, it will be the combination of buck and boost, but behavior mostly depends on that boosting mode. So it will be just like boost mode. Here also, again, that RSP0 problem will be there. And here also there are similarity while selecting the switch. When switch is turned on, it will be only limited by the inductor. And if it is a pure inductor, then the inverse current will be at least 10 times higher than the rated current. So this switch has to withstand that amount of inverse current. Okay, here the secondary side again, the due to the this diode discontinuity and the higher ripple current, the capacitor selection will be stringent. You should select the capacitor with lower ESR value, just like boost converter. Okay. So this is all the equation, peak to peak current expression. Here again, it depends on that. You see that inductor value, if the inductor value is more, then the ripple current will be less. It also depends on the switching frequency. Output voltage is opposite polarity to the input. Here capacitor is only charged in this pattern, so output is always opposite to that input that you know. But anyway, you have to avoid in some applications. That can be done in some modified topology of in the form of buck boost converter. Later on we'll discuss. So here again, this buck boost converter prefers to operate in discontinuous mode, and from this basic empirical relationship, we can find out this expression. And from this two expression, not only that, from the basic concept, here you just see, if I compare for equal power rating, boost converter as well as buck boost converter, since this inductor is in series with this supply here in boost converter, so the required inductor will be less compared to the buck boost converter for equal power rating. And this is again may be verified by this expression. Here the expression is related to half RTD into 1 minus d square. But in case of buck boost converter, here it is related to half RT 1 minus d square. So d is always less than 1. So that indicates that the expression, the required value of inductor and size of inductor for equal power rating of two converter, in case of boost converter, the requirement of inductor as well as size of the inductor will be lesser than the buck boost converter. That is another important criteria observation. Okay. Similarly, you will find the equal the same expression of ripple voltage, which is similar to that boost converter topology. This is another buck boost form, the tube converter. Here you just see the advantage is inductor, presence of inductor both at the input side as well as output side. So the input current ripple as well as output current ripple will be lesser. You are getting both advantage of boost as well as buck boost converter. Just like buck boost converter, it has having excellent filtering capability. So ripple current at the secondary side is less. So the selection of this capacitor may not be that much stringent. But here this capacitor is a very large capacitor, because this the objective of this capacitor not only is to store energy but also to transfer the load on the on the secondary side. So here the series capacitor has to be relatively large and capable of handling high RMS current. So a low ESR is essential. And these are equivalent circuit during on and off mode. And from that, you can find out this empirical relationship that essentially leads to that VO by VE, that is nothing but D by 1 minus D. So it is essentially a buck-boost converter, but having some advantages over buck-boost converter. Okay. There are different other switching topologies like edge bridge converter. These are mostly looks like edge bridge. So this is called asymmetrical bridge converter. Here, two switches are there in the diagonally opposite side, and two diodes are there. So when the two switches are on, then current will flow through this path. So full voltage will appear here. Supply voltage will appear across the load. And when the switches are off, the inductor, you know, the property of inductor, it will try to oppose any sudden change of flow of current through it. So by reversing its polarity, due to that, these two diodes will conduct, so current will flow in the same direction, but the polarity across the load reverses. So it will follow this kind of voltage relationship. V output voltage is related to 2T minus 1 into Vs. During any chopping cycle, the mean DC voltage appear across the load is given by this equation. And if I compare with the full bridge or half bridge topology, it requires only half the number of switches and diodes than the full bridge circuit, and it is capable of applying bidirectional load voltage similar to full bridge circuit, which will be useful for applying isolated mode of converter for battery charging applications. And this is half bridge topology. Here only two switches are there, but you have to use two capacitor here. Now if you connect capacitor like this across the switches, so it is assumed that the capacitor having same value, and theoretically though this voltage will be balanced by equal amount Vs by 2, but care has to be exercised in balancing the charge of this capacitor by proper design measures by either external circuitry or by using any modulation, advanced modulation technique. Otherwise, there will be imbalance of capacitor, and then capacitor may damage one of the capacitor, particularly the lower capacitor. We have experienced that it may damage due to overcharging after some time. This power amplifier has the disadvantage of derating the supply voltage compared to this half bridge, this asymmetrical bridge or full bridge topology. But of course, there are certain advantages because of presence of this capacitor. It will block any DC component. And not only that, here when this switch is on, you just see the current direction is in this direction, and when this switch is on, it will be just reverse direction. So not only the current flowing through this load is bidirectional, but the apparent voltage is bidirectional, but current flowing through the load is also bidirectional. So all four quadrant mode operation are possible, and that is also applicable for motor drive applications, particularly if you use DC motor for electrical vehicle applications to operate in four different quadrant of operation. Okay. And bridge converter, if you replace the two number of capacitor by the two switches, then it requires 4 number of switches, and definitely you have to it can handle large amount of power for large motor drive applications. Okay, circuit of course will have a better properties such as faster dynamics with a smaller current ripple under the same DC link voltage. Okay. And of course, four quadrant mode of operation are possible. Here you see, if these two switches are on, then current flow direction I already discussed in this direction. When these two switches are on and these two are off, then it will be on the other side. Suppose none of the switches are on, then also current will flow through either this path or this path. So all 4 quadrant mode are possible, and this is applicable for high power rated DC motor, particularly used for electrical vehicle. But it is a complex, of course, because you have to have that 4 number of drivers. But these 2 switches, fortunately, having in common source configuration, so it can be derived from the same power supply. But for these 2, you need to have 2 isolated power supply. There are, other than these, there are other converter topologies also. This is one single switch based converter topology. It uses only one switch. You just see the working of this one. When this switch is on, full supply voltage will come across these switches, across the switch, and this time that this diode will be reverse biased because of this polarity of the coil voltage. Now there is one capacitor and resistor are connected. Usually call it CDUM capacitor, damping capacitor and damping resistor. And this capacitor, during one period of the switch, it will try to discharge through this resistor. Okay. Now when the switch is off, the polarity of this coil will reverse, and this diode now will be forward bias, and this capacitor will be charged in this path, and this capacitor voltage in effect will come across the coil voltage. So it may also have the property to have equal amount of positive as well as negative voltage, because this is required sometimes to demagnetize, quick demagnetize of your coil. Okay. And this is only possible for maintaining the equal voltage-second relationship. So it uses only one switch and one diode, in contrast to 2 switches and 2 diodes in asymmetrical bridge converter. But it can have the similar voltage relationship, output voltage, output to input voltage relationship, if we maintain this kind of voltage relationship. And that is only possible with your predetermined circuit parameters, the resistor and capacitor. Okay. And there is the important thing is that there is no requirement of gate drive isolation. You can provide always, it is always better to provide gate drive isolation. But while going to the multi-coil application, suppose SRM motor nowadays, you know, switch reluctance motor is very much useful for electrical vehicle. So SRM motor having 4 coils, so 4 coils may be connected by this single switch based converter like this, and all the switches are having in common source configuration, common source. If it is common source configuration, if you just see, if it is a MOSFET, then this side is source, this side is drain, and this side is gate. Okay. So these all source point are connected in the to the ground point. Okay. So one power supply is required, is sufficient enough for driving all the drivers of these 4 switches. And these particular applications, of course, it due to use of this resistance, you know, the circuit will be not much energy efficient. This power circuit topology can easily be extended to multi-coil system like this, such that the gate drive signal may not need the weak isolation, galvanic isolation. Moreover, all amplifiers may share a common energy dump resistor circuit, and the circuit, as I told you, is not energy efficient because of the presence of these inductors. But of course, for low power payload applications, low power applications, maybe for driving a small scooter for electrical vehicle, you can have this type of power circuit. It is less stable than the, of course, H-bridge power supply. If I go to the modeling part, then it is clear. Moreover, the circuit produces more current ripple as well as lesser bandwidth. So these are all negative side of this converter. But see the advantage, just using one switch, you can excite the SRM, 4 coil of SRM, which is very much useful for EV applications. Now coming to the isolated switch mode power supply, you know that there is a need for isolation from input side to output side, and for that isolated DC-DC converter are useful. There are certain advantages. The output side is electrically isolated. This side ground is different than this side. Output voltage can be varied with trans ratio, because you know the basic buck boost and buck boost, all this converter topology, either you can transfer the this voltage from input side to output side not more than 10 times because of the circuit limitation. So if input voltage of a buck converter is 50 volt, you cannot step down beyond 5 volt, or if we have input voltage 5 volt, you cannot go for say 100 volt. Okay, but it is possible in case of isolated switch mode converter because of using this transformer. So output voltage can be widely varied with trans ratio. The polarity and step up step down restriction of the basic circuit no longer applied, because you can easily connect the circuit as per as your requirement by changing the polarity concept. Just like here, if I connect like this, so if I have a dot here, you just put dot on other side, and circuit connection if we have it like this, where inductor and capacitor is connected just opposite to other side, and there you will find this output voltage is just inverted. So here you get positive, negative, and based on coupling you may get the different level of voltage. So more number of multiple outputs at different voltage level can be obtained. On the other side, the introduction of this with this transformer will add the size and weight, and mostly that introduces other losses into the circuit. For so in terms of efficiency, it will be reduced because of the presence of the transformer. The eddy current and hysteresis losses will increase, and size and weight of the SMPS will be also further increased. But there are many advantages and number of advantages that outnumber these disadvantages. So that's why this isolated mode of converters in the form of flyback, forward, push-pull, half bridge, full bridge we are using. So this is the simplest fast topology of forward converter. Okay, so single switch based forward converter. This is the fundamental, the basic circuit. But the problem of the circuit is that here when the switch is on, it is getting the, if we see the voltage pattern here, when the switch is on, full supply voltage will appear. When switch is off, zero voltage, and then again the pattern of voltage, either it is more than zero or zero. So the average voltage is always positive, means DC. So there is a chance of saturation of the transformer core. So you have to avoid that one. So there are different techniques. One of the techniques, just using another third winding, usually called tertiary winding, is connected like this, and you follow the polarity, right? When this switch is on, this is dot, this is dot, and this is dot. So energy will be transferred from primary to secondary side, because this diode will be forward biased. Okay, so the inductor will be charged during on period, like simple buck converter. These all converters are derived from basic buck converter. But during this period of time, this diode will be reverse biased, so no current will flow through this path. But when the switch is off, all the polarity will reverse, and this diode will be forward bias, and current flow will be there with the third winding. Now, if the number of turns of third winding, means tertiary winding, is same with the primary winding, then equal amount of voltage will apply here by means of induction, and it will just polarity will be just opposite, and here in the primary due to the tertiary winding, the equivalent amount of negative voltage can be applied. Okay, and due to the applications of this negative voltage, this magnetite there will be no chance of saturation because core will be the primary will be demagnetized. Okay, so tertiary winding is required for resetting the core. So generally the duty cycle may not exceed because of this may not exceed that beyond 50%. Okay, so low current ripple does not place heavy duty, just like concept of buck converter. Because of the presence of inductor, the low current ripple does not place heavy duty on this capacitor because the ESR value will be lesser. Transformer implementation, of course, it is poor because it is only used for when the switch is on. During on period, only the energy will be transferred. And it is just used 50%. Normally used in continuous conduction mode, just like buck converter, and suitable for application up to say 500 watt. Efficiency can be increased if I replace this diode by the MOSFET switches and operating in synchronous rectifier mode. Now, if I use the asymmetrical bridge converter in the primary side, then also you may apply the equal amount of positive as well as negative voltage across primary. But of course, the voltage rating of each switch, then it will be just half. That is advantageous, because in this case, if we see the voltage rating of the switch, voltage trace of the switch just double, because it will not only be the supply side supply voltage, it will be added with the voltage applied by this tertiary winding. So VD plus VD, that means 2 VD will appear when the switch will be off condition. So the voltage trace maximum is the 2 times of the input voltage. Of course, when the turns ratio of the tertiary winding just similar to turns ratio of the primary, that does not mean that you cannot increase the duty cycle. You can increase the duty cycle if the number of turns ratio of the primary is more than the tertiary. Then you can have the voltage pattern of primary something like this. Sorry, you can have the voltage pattern of primary times. So anyway, you can see that times you will find this much. So here during uptime, to make the volt balance equation, here the height of the voltage is reduced, and here it should increase much due to that number of turns of primary, but duration of uptime is reduced so that your duty cycle is increased and it is more than 50%. Okay, so you can also having the parallel connection, and this paralleling of this converter will provide higher power capability, higher system reliability, and of course the increases effective switching frequency. Okay, there are many advantages, and usually we do for the large power applications, for battery charging or electrical vehicle or solar cell applications. Then this is the half bridge converter. Half bridge converter is connected in primary, so the description already given. Here, the only difference you see the secondary side, we are using the center tap transformer. So that transformer is used both in this cycle when T1 is used, then D1 will be forward bias. So in this duration, it will be only for T1 D1, and when T2 is connected, when T2 is on, then D2 will be conducting. So in this cycle, T2, D2 will be connected, and during this phase, no switches are on, and during that period of time, the inductor will be able to discharge its energy. And so the pattern of inductor current, something like this. So effective your time period is increased from this point to this point. So your DC gain you can find out from the basic fundamental, and it is balanced by n times into duty cycle. So depending on turns ratio, you can widely vary your output voltage from the input voltage. And the advantage, as I told you, the capacitor will block any DC component to the primary. That is advantages to avoid the saturation of the primary core. Duty ratio of each transistor, here since this transistor are in series, so you have to provide some blanking dead time so that it will not short circuit, it will not turn on at the same instant. And to avoid this short circuit, you have to provide the dead time. So duty ratio of each transistor must be limited to 50% to prevent both transistors on simultaneously. Here transistor, this transformer utilization is better than the single switch based full bridge converter topology, this forward converter topology. And two transistors are connected in series, so two isolated power supply are required. Power rating can be increased from 500 to 2 kilowatt applications. Okay. Full bridge topology, the full bridge converter here connected in the primary side, and as usual here the secondary side is connected like this, and DC gain is just double than the half bridge topology. The output power is double than the half bridge topology. And here for blocking the DC component, you can also put one capacitor here that will helpful for that balancing the voltage across this primary during turn on and top the full positive half cycle as well as negative half cycle. But here, of course, two extra transistors are required that I told you earlier, and you have to take care about this complex circuit, but it will be used for high power applications. Okay. Push-pull converter is very compact, and here only two switches are there, and two switches are connected in common source configuration. But with this converter topology, it is you can provide that DC gain just double than the half bridge topology, just like full bridge converter topology. But only problem here, the this primary is also, you just follow, it is a center tap transformer. So you should be careful so that the number of ampere turns N1 and I1 should be equally balanced by N2, I2. So to avoid that any flux imbalance in the primary. Otherwise, there will be a problem of the switches, and the majority failure of this push-pull amplifier due to this flux imbalance in the primary side of the center tap transformer. So switches can be controlled from the common reference voltage. Transformer utilization is much better than the forward converter. And as I told you, these switches should conduct for exact equal period here to avoid to maintain the volt second across the two primary, and that must be same. But here switches need to have voltage rating double than the input voltage of your forward converter topology, because here the supply voltage here, since there are two winding, and if you have the equal number of turns, then this VD will be added with VD, and these switches have to have that maximum stress of 2 times the input voltage. So while selection of this switch, you must be careful about this voltage stress rating, current stress rating, all these things. Okay. And this is 5F topology. Basically, it is derived from basic buck-boost converter. The circuit looks like very simple. Here you see, here, the one time you have to store the energy in the primary side. So if it is not like if it is not like a simple transformer that you have used earlier for forward converter, rather than that, it should have the inductor transformer. Here the one component is an inductor with a secondary winding. So you can make suppose if you have a circular winding, so if you just have a air gap, if you can provide, because considerable amount of energy will be stored in the air gap, because you know the ideal transformer cannot store energy. Okay, so so you have to take care while designing this inductor transformer in case of flyback topology. Otherwise, just using only one diode and one capacitor, you are getting this power supply, and if you can connect so many in the secondary, there multiple secondaries are possible. And here the advantage circuit is compact. Basically, majority power supply of electronic computer supply as well as television set power supply is based on this flyback topology, because if you just operate duty cycle beyond 50%, you can boost up the voltage just using this converter topology. Because if you want to go for the boost converter, isolated mode of boost converter, it is not there in the circuit. But in that case, the circuit topology is little bit complicated. You must have port number of switches in the primary and secondary, of course, as it is like forward converter. And here, port number of switches should be there for boosting up your voltage. And these two switches are to be on, say, during charging. Either these two switches or these two switches should be on for charging this inductor. And then the diagonally opposite switches are to be on for transferring this energy from primary side to secondary side. And you can find out that this will be a topology of for isolated boost converter. So to boost the from primary side to secondary side in isolated mode, your circuit, this topology will be a little bit complicated. But in flyback topology, if you just operate more than 50% duty cycle, just using this only one capacitor, one resistor and diode in the secondary side, you can boost up. And that's why it is an attractive circuit of this power electronic supplies and PS for electronic power supply for TV set as well as computer power supply. But of course, there are certain problems. Here also you have to take care, because it will also commonly used will be in discontinuous mode. Peak transistor current, here this large filter capacitor should be used with low ESR value. Okay. And you have to take care about the design, because this inductor are not be just like that your simple buck converter, because this inductor will be in the primary side. So this inductor will be referred in the primary side with that. So the expression of the inductor is just half with the n square number of turns ratio referred to the primary side. Okay. The current ripple is expressed by this expression, more commonly used in discontinuous mode. This is an attractive circuit for a number of independent output, but of course high peak transistor current, larger filter circuit with low ESR, very common power output. Okay, so this is one design example. I have to be a little faster because these are all basic circuit. So for these applications, just a minute. So one design problem here, input supply is given, suppose 300 volt plus minus 10%. Output voltage is 5 volt. Output voltage ripple is less than 50 volt. Switching frequency is 10 kilohertz. Output current is varying 3 to 30 ampere. So here you see you have to judiciously select the topology based on the rating. Here rating is only 150 watt. So even single switch based converter can provide this much of rating. But you follow that input voltage maximum varying 330 volt and minimum value is 270 volt. even though the large variation of voltage, your output voltage will be maintained constant, 5 volt. And in open loop, of course, it is not possible. So you have to take care about the closed loop control, either voltage mode control or current mode control. And on the other side, if there is a variation of load current from 3 ampere to 30 ampere, still output voltage will be maintained constant. So all this will be taken care to select the number of turns ratio from the basic fundamental equation and the inductor value from the derived equation from earlier, as I told you, that half R T D 1 minus D. So these all parameters are there. After getting the inductor value, you will select the value of capacitor. Okay, the ripple current from the expression. What is the ripple current expression? You can find out because you have to determine what is the value of ESR, because while purchasing capacitor, you have to also specify the ESR value along with the voltage rating of the capacitor. The transistor, selection of transistor also, the 2 into the VI maximum voltage and multiplied with that say some factor of safety. So say 1 kilovolt is the voltage rating. Similarly, you can select the current rating from the output side and multiplied added with this ripple current and transfer to the number of transistors of the primary side. There are control requirements and technique. As I told you that for making the control in closed loop control, particularly that your power supply should maintain good line regulation, means even there is a fluctuation of voltage, say this much voltage, your output voltage should maintain constant. It maintain good load regulation, means even there is a change of output current, your output voltage should maintain constant. Okay, so that there are certain expression, I am not going to details about that. It should have good transient and steady state performance due to variation of any sudden change of disturbance. It should perform well and it should maintain stability under all operating conditions. So you all know the basic that control in closed loop. It is there just using direct duty cycle control. So these are fundamental things. You have to sense the voltage, compare with reference, then compare with sawtooth generator, and there you can control this. So this is basically voltage mode control. It is simple and reliable. Load regulation is also good, but if there is sudden change of input voltage here, then it cannot quickly maintain the output voltage. So line regulation is poor. So you can do better by just using this voltage feed forward control, where there is a technique that you have to sense the input voltage also, and your sawtooth output is proportionally changed with the change of input voltage, so that instantly your control signal is here. So your output, the duty cycle, instead of this one, it will reduce immediately to this one, this instant to this instant from this input side itself. So you cannot wait up to few cycles. Okay, so immediately it can compensate that any change of input side voltage, and output side voltage change or output load regulation as usual, it is also there. So both line and load regulation is good, and output is no longer dependent on the input voltage, and that can also be verified from this expression. Closed loop response is also better. But usually almost all PWM chip that you have used in power electronic circuit for making all this converter used for EV or any applications, that is connected, that is in the form of current mode control. So current mode control, almost similar logic is there. Here you have to use that one RS flip-flop. And when this clock falls, when they send the pulse to this flip-flop, your transistor will be on. You just follow this diagram. So this is the pulse pattern, means this will give your switching frequency. Now when there is a high pulse, then transistor will be on, as well as inductor current will try to follow this at steady state, this VC, that means the control voltage which is coming here. And as soon as it takes the control voltage, it catches the control voltage, your reset pulse will be generated and transistor will be switched off. Okay, so this will be the pulse duration for your transistor. So here both line and load regulation is excellent, because you see from the basic fundamental equation, if VO is reduced, say, then VI minus VO will be larger, means your DIDT, rate of change of current, will be faster. So it will quickly catch this voltage so that your reset pulse will be here instead of here, so your on time will be reduced. Okay. Similarly, from the input side, if there is a change of input voltage, then also it can be taken care. Okay, I'm just be quick to complete my all slides actually. So a closed loop transient response will also be better. Current limit protection can be easily implemented by putting, say, one Zener here, by putting a voltage reference, by putting one Zener. It removes one pole, thus simplifying the compensated system, because this is a current mode control. So the magnet time constant, it can be that it can take care, it can be taken outside, and it will take only the system with other than that pole. Okay. So if you can see the voltage versus current mode control, the voltage mode control is a single loop control. So here only one controller, voltage mode controller, you have to design if you go to the control concept. And here you need two control loop, but it is of course a better and efficient control. Here both voltage mode control and current mode control, current controller are used. But this current controller should be faster than the voltage, because since it is a inner loop controller, this inner loop controller should be at least 10 times faster than your current mode voltage mode control. Okay. Now, so far we have done something about the working principle of different converters, then their power electronic control method in brief. But until unless you design this control, means what we call real-time control, means your classical control, you cannot provide the stability as well as performance in closed loop of this type of converter system, which will be used for different applications. So what do you have to do? First, you have to go for the modeling of these different converters. Okay. Now, switch mode converters are nonlinear in nature, and it is time varying. Parameters also time varying. So you have to linearize about an operating point. So mostly state-space averaging technique are used, which approximate the switching converter to LTI system, where there are some assumptions the filter corner frequency should be much less than the switching frequency, and you have to neglect the high frequency components of the converter quantities to focus the only dominant dynamics of the system. There are 4 steps involved. You have to first do the state phase model during on period and off period of any converter system. Then you have to go for duty cycle averaging. The next step, so if I go for duty cycle averaging, then all the equations are nonlinear. Then you have to linearize by means of perturbation technique. Here, small AC perturbation analysis was done. So here you just see that instantaneous quantity has been separated into 2 parts. One is big one, that capital one, that is at steady state point, and this small x hat, and that is the AC component. I will take care about any perturbation around the operating point. So these parameters, voltage, duty cycle, all the parameters are perturbed around an operating point. So these are these after putting this, you can separate out the AC and DC component, because DC component you can put in the form of this, and derivative of DC component will be 0 because this is the constant value. So you have to take, you can take the Laplace of the AC component after transformation of AC equation into S domain Laplace. Then you can find out the output to control transfer function, and this is very standard form. Whatever be the converter structure, this will be the standard equation after finding A1, A2, B1, B2, and all this. If you put in this expression, you will get output to control transfer function. Why it is important? Because you see this in voltage mode of control here, this controller you have to design. This is the PWM control block, so which will give the duty cycle to the converter, say DC-DC converter here, and output is the output voltage. So output to control, if you have to find out this transfer function, okay, instead of output to input voltage, you have to find out output to duty cycle, output to control transfer function. And with this method, we have done with the different boost converters. So this is about boost converter. So there are two modes of operation. We are not going to details about that. So you see that you have to write all the equation from basic Kirchhoff's voltage law and current law, and then you have to go for the averaging. Okay, here we have considered all the circuit parasitic elements like series resistance of inductor as well as ESR value of the capacitor. Okay, if you consider all the parasitic elements, then your transfer function will be more closer towards the exact thing. Okay, so that you can get the simulation result almost equal to your that practical result. So after finding these all equation, all components, here you are putting the output to control transfer function, and this is the final form of transfer function. This is the final form of transfer function, though it looks a little bit complicated, but here you can find out. So these are the second order poles, because you have only two energy storing elements. And here what is important, I told you earlier, while going through this model, you find that there is one right up in 0 that is appearing in the transfer function, and this 0 probably due to the ESR value, that RC of the capacitance. Okay. Similarly, if you go for the modeling of buck boost converter, here also you find the similar structure, almost similar structure. Here also you find that one RH30 is there, right up plane 0 is there. Due to that, what will happen? System will behave like a non-minimum phase system. So it will provide more phase lag. So more phase lag means you have to compensate by additional phase lead compensator, like type controller, type 3 controller, that I will come later. Okay, and normal say PD or PID or lead controller cannot do that. So a discussion on the right up plane 0. The presence of this right up plane 0 can be explained by noting that if a boost or buck boost converter operating in continuous mode, then the duty cycle is increased instantaneously. The output voltage will decrease momentarily because the inductor current has not had the value to increase, but during the time interval, means of time, the inductor transfer the energy to output stage has suddenly been decreased because of the property of inductor. So this initial decline in the output voltage with the increase of duty cycle is just opposite, which eventually takes place. Now these effects result in right up plane 0, which introduces phase lag in the control to output transfer function. In a buck boost or flyback converter operating in discontinuous mode, that effect will not be there. Okay, so that we have to taken care. Therefore, in discontinuous mode of operation, RSP0 in the transfer function will not appear. Okay, so that we will see while going through the control and while going through the different topology. So here now the design and implementation of different controllers like type 2 and type 3. So you need to have very fast transient response for your switch mode power converter for some typical applications, whether it is applicable to renewable linear solar grid system or electrical vehicle or maglev system. So fast DC-DC converters are essential, and that should work in closed loop manner. So improving the performance of DC-DC converters is one of the major goal for designers. So several control methods are there in literature. Due to the time varying and switching nature of power electronics converter, their dynamics, behaviors are nonlinear, as I already discussed. Conventional controller like PID control, the tuning may be very difficult for such type of achieving this type of dynamic fast response. So we will use what is type 2 and type 3 control to make the parity. Type 1 is also there. This is just like indicator. We will not use this one. But if we have a structure like this one, additionally, to reduce completely the steady state error. So this is the structure of type 2 controller. And type 3 controller, there is additionally, it is not like lead lag controller. There are two lead controller connected in cascade, additionally one pole at origin. Now it is found that if these zero locations are at the same location, like this omega z and omega similarly pole location at the same point, then you may find better control performance. So the design of this type controller is firstly introduced in 1983 by K-factor method by this fellow H. Dean Venable. What is K-factor? K-factor is defined as the ratio of square root of pole frequency to zero frequency for type 2 controller, or ratio of double pole frequency to double zero frequency for type 3 controller. Here you find that type 2 controller is used for exactly means nearly up to the 90 degree theoretically, but it is not possible practically. Phase boosting is possible. For type 3 controller, you can go up to 180 degree. Okay. Now this is the example of case of boost converter. So this is the transformation model and drive. So after putting these parameters, you find this numerical value. So after getting this value, you have to design this type 2 controller. So this is the basic structure and this is the Bode plot. So here you have to select this frequency so that here maximum phase boost, and this phase boost is possible just like simple lead controller only at the geometrical mean of this pole zero location. So here, as per the definition, the K factor, I will provide the slide. I will not go through details. The phase boosting is possible maximum by this equation. Okay, and you can find by after putting in terms of K, that K in terms of phase boosting and pole zero. Finally, in one trial, you can find it. What is important that you can find out the pole zero location if you assume that how much phase boosting is required and what will be your cutoff frequency, the corner frequency of this controller. So from that, if we assume that crossover frequency is 1 kilohertz and this much phase boost is required, then you can find out this pole zero location, all this pole zero location. So the transfer function of type 2 controller is this one. Now there are some simulation results. You find that how the gain effects of these all responses. So you should not take large amount of gain. Similarly, you should not take lower amount gain. These are all control concepts. so that if you want to see the performance, this middle one taking this gain is giving the better performance. Okay, so these are all the tabulated results. Here you see that this is comparatively giving better performance than this one and that one. Similarly, with the change of the crossover frequency, because the crossover frequency also directly influence the pole zero location of the controller, and you have to judiciously select the crossover frequency also. So these are all about this design. Similarly, you can also design the type 3 controller by K-factor method, and these are all performances. Okay, these are observation table, and you can find with the different values of gain as well as crossover frequency. And finally, you can see that after getting the parameters, you can also optimize by soft computing technique. One of my students has done this with comparison with different soft computing technique like GSA, PSO, and GA, and it is found that for this particular operation, this GSA-based type 3 controller will provide the best performance with having 0% overshoot and a very fast transient response. And in terms of frequency domain also, it will provide large amount of gain crossover frequency and have a very good phase margin like 79.30 degree and very and also gain margin. Okay, large amount of gain margin. So this way you can design the controller, and you can find that in closed loop control, you can also all these things you can operate after getting controller by using DSpace or any digital platform. So this is one schematic diagram just using DSpace platform, and these are that how you can make the circuit using DSpace platform. But while using DSpace type costly controller, you have to take care for signal conditioning, different signal conditioning circuit, just like filtering and attenuating the voltage which is inputted to your DSpace, and it should also be isolated from this circuit. Here this voltage sensor which is used LA25P that isolate the load side and this side, and this side again you have to use the opto isolator which also isolate the controller side as well as the power circuit. Okay, and this is a typical hardware circuit. So these are all experimental results. Okay, with the state change of the load change, how your comparison with normal type 3 controller and optimized type 3 controller, you see this one showing better response than that. Okay, now come to that, keeping in mind this is the hardcore, that this research is completely in our own research and developed in our laboratories, different converter. What we found that the basic problem of this boost and buck boost converter, which are having the right half, not only right half zero problem, it is also having higher ripple content in the source current and output voltage, limited voltage gain. That is very, very important because you have to use in electrical vehicle like fuel cell, and particularly if it is operated by solar system, EV integrated EV electrical vehicle, there you have to have large gain. But usually with this boost converter, buck boost converter, because of so many problems, you have to rectify, you have to have better topology of converter, and that's why we are using this tri-stating technology that will show. It is very difficult to understand in one lecture, but anyway, I will just demonstrate interleaving technique, and of course the connection in series at the output stage to increase the voltage gain, and sometimes combination of all these three will give you that one solution to have better efficiency, as well as it will provide higher gain, as well as it will reduce the ripple content. Now, what is tri-stating technique compared to this normal boost converter? You see one more switch is used here across the inductor, and other than boosting and discharging state, there is tri-stating state, and this is actually called freewheeling state. And it will be freewheel when the switch is on. The stored inductor, part of the stored inductor will be freewheel through this path. Even though if I go for this relationship, it will still maintain the boosting property due to this relationship. Now, once again, you have to go through the different modeling. I am not repeating, and you see while comparing these two, you see while going to output to control transfer function of tri-state converter, there is no right of plane 0, but it is there in case of normal boost converter. So taking the similar parameters, you see the response in open loop. In case of boost converter, normal boost converter, there is initial undershooting before going to this attaching to this your steady state value. But in case of tri-state converter, there is no undershooting. And in case of phase concept, means in frequency domain, it provides a large phase lag compared to this one. So all these things, these are all steady state responses, these practical responses, and these are practical response. You just see, this is showing only the response of tri-state converter. It is almost catching your that square wave state input, so very fast response. That in the same diagram, you see the current voltage, coil voltage responses, and this is a typical diagram. This part of work has been published in this particular journal, and here also the same logic is used for tri-state buck boost converter. And here you see, after modeling with consideration of this parasitic element, even you will not find that RSP0 in the control to output transfer function. And this is a typical circuit, just with the analog circuit, it can be controlled. And here it is comparison is done with the normal buck boost converter. You see in similar diagram here with the change of load, how that this response affects in case of buck boost converter. But in case of tri-state buck boost converter, it having a little overshoot and very fast response. And it is not only in positive step, it is also clear from negative step during negative step of response. Okay, so this is all about the concept of tri-stating. Now the interleaving concept. Interleaving concept, most of you know that things have to be connected in parallel to get certain advantages like better power handling capabilities, to improve the efficiency, to reduce that kind of EMI problem, as well as current ripple, particularly at the input side as well as output side. So here, basically, you have to connect as many, going for this concept 360° by n, where n is the number of converter connected like this. Okay, so but here problem also still there, even if you go for interleaving, because this right of plane 0 still problem will be there. But since due to connection of this interleaving, you are getting certain advantages. That advantage you can see with this analysis. Okay, this is the closed loop circuit diagram, and this is the simulated waveform, and this you see the practical waveform. While going through the practical waveform, this is the input current, and this input current, as you follow from this, these are the two current. Okay, which is not perfectly at 50% duty cycle, but if it operates at 50% duty cycle, then this current can be minimized. It may not be zero completely, but the ripple input current, that current will be minimized. Okay, and it is not shown all waveform, but in this graph, in this table, it is shown that how with duty cycle that different inductor, the ripple current, ripple expression like inductor current input current ripple, inductor current ripple, and output voltage ripple will vary. And it can be shown in better way with this waveform, that with the increase of ripple current, whatever be the ripple, all ripple will decrease. And at any operating point, your normal boost converter will exhibit the better, higher ripple content either in the input current or output voltage or inductor current ripple, okay, compared to interleaved boost converter. Okay, so these are the circuit, this hardware setup developed in our laboratory, and this particular part has been published in this journal, FDP journal. Now this concept, the two previous concept, the interleaving and tri-stating concept, now embedded as to get the both facilities, and it has leads to the tri-state boost converter. And this is the circuit structure. So you must have different mode of operation. Here we have selected 6 different mode of operation, and for assumptions, for simplifications, considering these duty cycles are equal, only delta 3, which one is delta 3, when both inductor are getting charged, that delta duty cycle is variable. And even though still we find that the voltage gain is related with the 4 plus delta 3, so for any particular delta 3, it will always boost up the voltage. Okay, so this if we go through this control to output transfer function, considering all the circuit parasitic elements, the modeling is little bit complicated, but still we can achieve it. And you find that there is no RSP0 for this, because we have used both tri-state interleaved concept. Okay, and this is the complicated circuit diagram to implement in analog control in the laboratory, and these are the responses. As you find that ITBC in interleaved tri-state buck boost converter showing better response in terms of dynamic response and in terms of ripple content as well as efficiency. Okay, so this part of work has been published in IEEE Transaction in Industrial Electronics. Now that other problem which I told you earlier, the normal buck boost converter or boost converter having major problem of having gain, because you can't magnify that this amplify the gain more than 10 times in case of non-isolated type converter. And you can use this transformer using the transistor, but there are some problems of the transformer. As I told you, the losses will be more and size and cost will be more, and you have to design the transformer. But even using the transformer, not even using the transformer, just modifying the circuit topology, you can do some better in terms of gain. And there are certain which are already there in the literature, this topology as well as this topology. Now this is our modified topology where we find this, we are getting the gain is just square time the normal gain of buck boost converter, and that we can find out by steady state analysis. Okay, and we have 2 mode of operation. Either these 2 switches are on at a time, both switches are on, and this will be the equivalent circuit. During this period, both inductor will be charged and this capacitor will provide the load current. And during switch off condition, these 2 diode will be on, and these two diode will be on, and then an inductor will be charged this capacitor as well as this capacitor. And the pattern of voltage, inductor current, voltage is like this. So again, you have to go through the mathematical one, because this modeling part is very, very important. If you want to correctly design your controller in closed loop, and majority things, applications, whether it is a battery charge applications or closed loop motor applications or EV or PV, whatever it is, you have to do in closed loop. And majority people are not doing this, taking care about this part. They are arbitrarily selecting the PI controller or PID controller, but mind it, this will not give a better performance. Even sometimes the controller will run out of control and it will be on the verge of instability. Okay, so to avoid that, you have to correctly model it the way the modeling is done here. Okay, this is all standard modeling of that. Here you just can verify. Here there are 4 number of energy storing elements. So the order of the transfer function will be 4. So this is the equation in mode 1 and then mode 2. Then again go through the averaging and all this concept, and you are finding the final. And this is, you see, the 4th order transfer function. Okay, after putting all the circuit parameters, this you will get the numerical value. Then you using the type controller K factor concept or any optimization technique, you can find out. And what is more important, that you can find out a generalized controller for different converter system and then compare in a single diagram, and that is not possible for using the classical simple PID control and other control. Okay, so this is there. Here suppose you are comparing with the 3 different controller, with the 2 existing controller, with our proposed control. Here we find that this converter gives better response in terms of dynamic performance, tracking performance, as well as practical responses also there, and in terms of efficiency, because we do not have major component, and ripple also lesser than your conventional that converter usually available, eigen converter available in the literature. This is another topology, that input current and output series buck boost converter. This converter topology also newly developed in our laboratory. So their input side, the 2 inductors, these are connected in interleaving mode, and output side is connected in series. And there are different modes of operation. Okay, you can find out that equivalent circuit, and from that you can find that different equation. Even with the parasitic elements, you can find out that state 1, state 2, and find the control to output transfer function. Okay, then the design of controller and then responses, right? And you can have to compare with your closed loop response, means in experiment. Until unless you do the experiment in power electronics, there is no use of your simulation, because ultimately you have to use these things in experiment. Okay, so these are all ripple and efficiency analysis of this developed converter in input side parallel and output side series connected. And this part of work also published in this journal, IEEE transaction on industrial electronics in the year of 2020. Okay, so this what is our objective? Objective is, now I just want to tell frankly, means this is the standard diagram. It's a steel electrical vehicle drive system where you have to use the fuel cell, you have to use the supercapacitor, you may have to use battery. So there you may need some type of bidirectional converter also, like this converter. Okay, in bidirectional mode from primary, this only boosting from this side to this side, only boosting mode is possible, and from this side to this side, only bucking mode is possible. If you take the switch of these 4 switches, here the advantage is only you can go any side, either boosting or bucking from this side or that side, and it is applicable for any converter topology. And this is a dual active bridge converter topology. There also you find that when you have to transfer energy from this side to that side, it has to work in inverter mode, and this side you have to work in rectifier mode. and with the phase shifting property, power can be transferred from this end or that end. So come to this picture, whatever be, so suppose from fuel cell output is very low. So you have to amplify that with that DC-DC converter. Now, if you use the normal boost converter or this converter, that buck boost converter, then you may not achieve that the output voltage level, DC link level here. So what converter you can, it is always there in research that you can do your topology, you can develop your topology which will provide the higher gain. Just like the topology we have developed, that is maybe highly applicable, that IOBBC or say input parallel output series buck boost converter, or this kind of converter which is giving the square times gain of the input voltage. Okay, high gain buck boost converter. And this side, supercapacitor and battery charger, you need bidirectional converter. So this converter again you can modify in terms of dynamic response, as well as you have to decrease about the ripple and increase about the efficiency, and thinking about the gain. So this you can modify. So far as my knowledge is concerned, all these converters are conventional converters, mostly used in electrical EV charging applications. But here there is a scope to develop the new topology of this converter. Similarly, here mostly two-level inverter, because if it is a induction motor or BLDC motor, then you can have two-level inverter. Okay, so now two-level inverter mostly replaced by multi-level inverter topology. So two-level is replaced by multi-level inverter topology. So there also there are many research is going on to give a new topology or to improve your modulation technique, so that you need your requirement like very fast charging, very fast dynamic response in terms of efficiency. So there is always a scope to replace all this converter topology by using, say in this case, to drive your induction motor by using multi-level inverter. So many of you know about this multi-level converter. Just for the sake of completeness, only few minutes time is left. So it is there. This is NPC topology here. The level signifies the number of pole voltage, position in the fundamental cycle. Any level greater than 2 considered as multi-level. Here multi-level, here the voltage is, you just see the voltage at midpoint, this voltage, and across positive bus or negative bus or positive bus, or this voltage with the corresponds to the neutral point voltage. Here if I take the neutral point voltage, then the voltage level will be 3 VDC by 2 0 and VDC by 2 minus VDC by 2, so that you can find out when these two switches are on, then you can find out VDC by 2. When these two switches are on, then current will flow through this diode and this voltage across load will be 0. And when these two switches are on, okay, you just see that minus VDC by 2 will appear across the load. Okay, so this way you will get certain advantages if you can go for higher level of voltage, so that staircase waveform will get lesser TSD, better opportunity, better power quality, reduced DVDT stress on switching devices. Devices of lower rating can be used, lesser EMI, lower switching frequency, modular, simple structure. Particularly if you go for CHB multi-level inverter, so the structure may be something like this. Here, two HBs are connected in cascade in series, so that you may get by maximum 5-level voltage across the load, starting from plus 2V plus B 0 minus B minus 2B. So NPC topology or this CHB topology can be used in three-phase applications, just connection. So these advantages, there are several advantages as I told you. That reduces the switching losses, high efficiency. For higher number of levels, harmonic content will be low. But of course, there are certain disadvantages, particularly if you use that NPC or diode clamp, this one. Here you have to be taken care of this capacitor, that voltage balancing across the capacitor. And in case of this CHB inverter, you need to have the isolated sources. So these isolated sources have to provide for large power applications. Also, it may be suitable, of course, for renewable energy applications. So separately for renewable energy, different renewable energies can be fed back to this as input to this different converter, and you will get this output. So the number of output, whether it is a CHB or NPC, you can always increase like this. Say it is a 5-level NPC inverter, and if you can follow this empirical relationship to select the number of switches, number of capacitor, clamping diodes, and you can also use that thing in bridge form to have that now increase the line-to-line voltage. And you can also use in case of that three-phase applications. Okay. So nowadays, as far as my knowledge is concerned, for electrical vehicle applications, already multi-level converter in the form of this 5-level that ABB has developed, 5-level NPC topology that is used in drive applications also. So there are different classifications of this multi-level inverter, NPC, flying capacitor, cascaded edge bridge. Okay. Among NPC also there are TNPC, NPC, different, and it's one for reduced number of components of using that multi-level inverter. Cascaded edge bridge multi-level inverter is also equally applicable for equal number of voltage DC sources or unequal voltage sources. If you use the unequal voltage level sources, then just using with lesser number of diode these devices, you can increase the number of level. Of course, the number of redundancy states. These are, suppose in this case, it is possible to achieve this voltage V at least 1, 2, 3, 4 number of switching states. But if you use the unequal voltage level, then number of redundancy states will be decreased. So this is another point of disadvantage of equal unequal voltage sources. But anyway, you can. These are all now there in EV applications. So I think I have another slides, but anyway, this is for three-phase applications that already discussed. And just I want to finish because I have another meeting. So if you have any question, you just
Thank you, sir. Thank you so much for your informative talk. Audience, if you have any questions or anything you want to ask, you may interact, please. Participants, you may ask questions.
Okay, if there is no question, then
Yes, sir. Yes, sir. I think.
may I leave now?
Yes, sir. I think there is no questions. If they will have later on, I will forward you.
Okay,
Okay,
if
sir.
there is
Thank-
anything
Okay.
needed, then you can share my mobile number as well as email ID.
Okay, okay, sure, sir. So once again, thank you so much, sir, for your nice talk, and
Thank you.
just please accept our token of appreciation, sir. Thank you so much.
Thank you. Thank you.
I will communicate the other things in your mail or in WhatsApp. Thank you so much, sir. Thank you for
Okay.
your kind cooperation. Thank you so much.
Thank you. So I'm leaving, Dr. Kundan.
Yes, sir. Yes, sir. You may leave, sir. And if you in evening like 5:30 up to 5:45, that program will be there, sir. Like a Bera sir program. Okay, sir. So even 10 minutes, 50 minutes, you can join later on. You can think, sir. Okay, sir. It's not compulsory. It's a your choice, sir. Because I know his lecture is very like a very like a peaceful type.
Spiritual, okay.
Yes, sir. Yes, sir. So thank you so much, sir, once again for your support. Sir. So participants, it's 3:26. So just now I'm sharing the feedback link for this session. Just after 15 minutes, 20 minutes around, 3:45 we will be starting session by Professor Behra. We will enjoy that session. Thank you so much. Just I'm sharing the feedback link. Where is sir?
Sir.
Yes, sir. Yes, sir. Good evening, sir. So, shall we start, sir?
Yes, yes. Actually, my computer restarted, so 2 minutes
Okay,
late.
okay, sir. Okay, okay. You take 2-3 minutes, sir. No issue, sir. Okay, sir.
Sir, you can start or we
Yes.
wait.
No, no, we can start now, sir. Just a second, sir. Okay, so very good evening, one and all present here. Today we have with us Dr. Ranjan Kumar Behra, sir. He's from IT Patna. He's working there as an associate professor in the Department of Electrical Engineering. Apart from the technical works, he used to be executed in time to time and involved in all the project works. He is also a very good person and involved very much in ISKCON. So he will be delivering a lecture, Mind Secret, How to Achieve Success. So I think I'm very too small to describe about him, about the things. So better he doesn't require the any introduction for such type of lecture. So thank you so much, sir, once again.
Okay.
And we will enjoy your lecture, sir. Thank you so much, sir. Please start.
So thank you, Dr. Kundan, for inviting me. Especially, I'm very delighted when you invited me for this specially, more than technical, because the technical lectures are nowadays available plenty in the internet. And without going to college now, people are also learning by staying in the home. So, but this thing, which is very different, which is very important also in our life. So most of the time we generally don't give importance to this one. So I am very delighted and I'm very thankful to you for inviting me for these special things. Generally, I'm sharing my.
Yes, sir. You can share, sir.
So one may be thinking that, sir, I'm sharing this PPT.
Yes, sir. I have given the sharing permission, sir. Is it possible?
You have given it? Okay.
Yes, I have given, sir. Please check. Yes, yes, it is coming, sir.
It's coming?
Yes, yes.
Okay.
Yes. It is visible, properly visible.
Okay. Thank you, Dr. Kundan, for inviting me this one. I'm more thankful to you. Okay. For this only. Okay.
Thank you.
So
Thank you so
generally,
much.
I give this lecture to my students. Also, this lecture I have given many places, at least in 2-3 places in other country also, which is very important today. And today, by sitting in the home, people they get so many kind of diseases because they lose the interest for everything. And the problem in the family, problem in the society, problem in the nation, everywhere it goes one after another. This is like a fusion reaction that 1-2 particles they react, they start reacting and goes and increasing that reaction till it destroys someone. So that is why today you will see that there is a big chaotic between animal to animal and man to man, community to community, society to society, nation to nation. If you see, everywhere the problem of this is going on. But we try to solve it. For example, that we all are technocrat. We did so much research, but when the pandemic came, this coronavirus, our whole research, nothing worked. Actually, everybody, including doctors, they have to stay within the room actually. So then if we cannot, so many things are happening around. So how we can become an instrument in that is the most important factor. So this is I will speak about mind secret, how to develop, what is your mind and how this mind can play in our life. So already sir yesterday discussed. So today we are age up in the advanced technology, Industry 4.0, IoT, deep learning, and artificial intelligence. And now machine is speaking to you. Machine is controlling to you. If you bring a smart watch of Apple, you will see that after 20 minutes, that watch will speak. Oh, you are sitting for 20 minutes. Now you must stand up. So people are controlled by that way. So if you go to different countries, I have seen in the Hong Kong, there are these ships that they will tell you that, oh, 4 people should enter from this gate, 4 people will enter, and 2 people should go out, they will go out. This is how the automatic controls are coming into picture, and there are a lot of evolution. Flexible electronics, IoT, smart grid, smart management system, smart environment, everything is smart. But the human being, although we try to control the uncontrolled object, but you cannot control our own mind. That is what the secret. If you see, everyone in this world, starting from an ant to a big magistrate or maybe prime minister of some country, everybody is struggling somehow or other. A laborer is taking so much load. He has no interest, but he takes it. And the tiger fight for the deer fighting. And there are also for $1, wife, husband, they fight. And there are so many chaotic conditions. It is due to the sense and mind. Because everyone in this world, they wanted to conquer something just to satisfy their senses. Everyone of us. It is not that everybody is free from this. Everyone want. Like an ant think that I can lift this universe. So everybody is exactly like that. So I will tell very instructive story of an elephant. One elephant was a king's elephant. So what happened? There was a frog in a pond. And that frog, he got 50 paise coin. Nowadays, 50 paise is not available. But in our childhood, 50 paise means very big amount. So and one frog, he got 50 paise. So this frog thought that, oh, I got the 50 paise. I'm so powerful now. So he came to the road and king's elephant was coming for drinking water in that river. So this small creature, like the frog, he asked this elephant that, oh, I will not allow, because I am now the richest man, 50 paisa I have. So elephant never looked at that one. He put his leg on this frog, and frog died. Exactly, we also in the similar kind, we also struggle in this material world, and we also think that I can control something, but we cannot do anything. And the example is pandemic of this coronavirus. Everybody has to stay within the home without any complaint to anyone. And that is why the mind's mechanism, let us study the mind's mechanism. The mind is a very, 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 very complicated thing. And the intelligent is the decision maker. Is it audible to everyone?
Yes, sir. Yes, sir. Yes, sir. You are audible, sir.
Hello?
Yes,
Hello?
sir. You are audible, sir.
Hello? Yes. So the mind is the storehouse of thought and desire and your experience. So how this mind gains the information, the external world you are able to understand through this eyes, nose, tongue, ear, and skin. These are the 5 senses by which you come to know about the external world. And also, this brings you the experience. For example, you have eaten a rasgulla sometime back, and you want to eat it today. So before eating, your mind says that, oh, rasgulla will be very sweet like this. So that is called the impression or the experience. So if the mind is controlled, it is a very good friend to you. If the mind is not controlled, then it is very bad. That is in a surgeon's home, one knife can save the life, where in a miscreant's hand, it can kill others. So, because we do not have the control mind is not there. That is why there are lack of confidence within us, depression, stress, hypertension, weakness, loss of trust, dangerous diseases, damage to oneself and family and society. Sometimes these are lead to very crisis. And go today, 76% of the Indian youth are sufferer of all this list. So when I was in IIT Kanpur, I will tell very beautiful story that one of my friend, his name was Rajan Pandey. So this Rajan Pandey, he was, his father was a secretary in the Uttar Pradesh government, and his mother was a block development officer. And he did a PhD from IIT Kanpur with chemistry department, and he was working in the Maxwell Institute in Germany. So one day he came back to visit India, so he came to IIT Kanpur also. And the night, we all were sitting and we discussed everything till 12 o'clock. And after 12 o'clock, so we went to our room and we slept. So next day morning, somebody knocked at my door and asked me, Ranjan, this Rajan is no more. So I became very unhappy. When we ran to the top, we saw that he drank something which actually a lot of white foams were coming, and he is already dead. So I was just thinking on that day that a big man, his father built such a huge house, and his secretary's son, only one son, and mother also very high post, And he also earned more than $5,000 at Maxwell Institute. So what remains with what is the problem with that boy? Problem is there was no mind control, and there was some kind of distress or stress or hypertension. One of this kind is torturing him. So I thought that from that day, I thought that no, there must be some kind of the solution, which we are going away from our reality. So that is why there are a lot of mind-body connection. If you take the body is a gross, this gross body that can be they can change when there is an effect on mind. For example, there was one, you are coming from your hostel to the college and to meet with your girlfriend or boyfriend. You put lot of sprays and you are coming very nicely that I will meet. But in the way, your friend told, oh, where are you going? So you will tell, my dear friend, I'm going to meet my girlfriend or boyfriend. So suddenly he will tell, no, you have failed in this subject. Do you know? I just came, I saw the answer sheet and I came here. I saw that you have failed in that course. Suddenly that happiness, that the mood of the jovial mood will become completely morose. So this is what the nonlinear dynamic of the human mind. That is why, although the cognitive science, many people they have studied about the cognitive science, but they are not able to model like a physical objective model. F is equal to mass into acceleration. That model is no more valid for your mind and body relationship. That is why when the Sophia robot we made, we want to give the consciousness to that Sophia robot. But it is very only a limited consciousness you can provide, where Sophia can laugh at you and can make handshake with you. But Sophia, if you ask Sophia, are you male or female? She cannot say that one. She can say, you cannot say she is Sophia or he is Sophia. It is the Sophia. Why? Because there is some which is missing, which you have that one. And that is what the body mind, the connection of body and mind is so complex that hardly you can understand this. That is why when the gross material body is subjected to different kind of turbulence, that will affect on the physical consequences. That is why mind is the thought will affect on your bodily structure. So we will see some example. First experiment that Dr. Julie is a university graduate from University of Minnesota, and she was very beautiful, well-educated, attractive, interesting career, and she is a PhD. And from Minnesota, many students, they go there for doing PhD. But if you see her, there is a very great, not exactly. Julie also had diabetes, and while she loved her job, sometimes she feel anxious about running a business, and she became angry herself that why I have not gone for this. I remember when I joined in IIT Patna, that time there was one boy. His father had 3 petrol pumps, and that boy, what he thinks, you cannot understand. So sometimes he will do very good in the exam. Sometimes he will not do anything, he will not write, he will just scratch the paper and he will go out. So I will understand, you cannot understand. Many people have not understood it. And people will become very angry. That is why he has a mistake for that, but it is given here. Even scary, despite careful monitoring her blood sugar, she finds herself coma once or twice in a month. So from this study, you can understand that there are positive effects and negative effects due to the biological functioning of the bodily environment. And that is why the finally mind can affect your health. That is, many examples are there in India. I am not going to discuss all these exact. Second one, the second experiment is Dr. Wolf. He was a great, in the Baltimore, he was a great doctor. And every pregnant lady in the state of, especially in the Washington state, and they used to come to Baltimore for showing to this doctor. He was very famous. And when a pregnant lady, she comes there because they don't, if there are continuous vomiting, first thing he will treat him that, my dear lady, you came to the right place. And this here, if you go from here, there will be no vomiting at all. And then he will tell that this medicine you take, it is from a great pharma, and I have tested for 10,000 ladies. So when a pregnant lady will take that medicine, she will forget that there was a vomiting at all. So this is just a mind's play. Actually, he speaks in such a way that the pregnant lady forget that there is a vomiting. There are another example of in the Boston School of Medical Science that is called the placebo effect or blank pill. Okay, so when a diseased person will come, they will give a blank pill that please take this pill, and this pill you do so this pill you take it and you will not have any disease. So, but that is a blank pill. There is nothing. So I will tell one very beautiful story exactly like this. So this, because you have taken, oh, I have taken medicine. So when you take the medicine, automatically disease subsides. So they have seen that there are 50% success in this medical science that occur due to the placebo effect. I remember in my home village, there was a doctor. His name is Prasant Paingrahi. So he was a doctor, and he generally go to nearby tribal villages for treatment. So when he goes there, once he saw that he has taken the needle, but injection that he has not, he forgot the injection, and he took only the needle. So because they are the tribals, they generally very innocent. So this person will tell, oh, what happened to you? So they will tell that, sir, we are having fever. So he will tell, you look that side. And he will just push that needle and bring out. And that way, then you collect, please give 20 rupees. I have given one injection. So like that, the people, they have just given the blank injection, but they have charged 20 rupees of those people. And those people also, they paid because they don't understand. And next day when you go and ask your fever subside, yes, sir, we are very good. This is called the placebo effect, okay? And there are also nocebo effect, like you sit and think in your mind. I remember in my BTech in NIT Raukela, there was a student, his name was Partha Hari Mitra. So Partha was my roommate, and he was having fever during the mid-semester examination. It was like this winter season, and he was having fever. And he told me, Ranjan, if I cannot do good exam tomorrow, I will do something. So I thought that, okay, he will do. It was physics exam. And we all went for appearing physics. So we appeared physics exam. But while returning, so somebody told us, that Mitra is not here. I told, what happened? No, there is some dead body is floating in the water. So you see, just he was just thinking that I cannot do good in the exam. I cannot do good in the exam. I am having fever. Just by thinking that one, the depression came to him. And depression that took his life. And a backside of our hostel, there was a big pond. And in that pond, he did suicide. So that is why this is called nocebo effect. Just you think the bad about yourself, you will degrade it more and more. That is why you should never associate with a person who speaks bad about you or who speaks bad about others or who drags away your position that, oh, you are useless, like that. You should never associate. You should associate with people those who encourages you. So there was a positive here. There was Norman Cousins. So he was suffered from the blood cancer. When he was 5 years old, he suffered from the blood cancer. So in that 5 year old, then he has a father, his friend, he has a Dr. William. So he went to Dr. William and asked him, my dear sir, I am having this blood cancer. It will be cured? So he told, no, it is very difficult. Out of 500 people, one may alive. So Norman Cousins became very distressed that what he will do. But he did one thing, that he go to the nearby shop and collected humorous movies, joke movies, comedy movies, all comedy, 500 set of comedy movies he took. And then he played that comedy movie, and each day she was laughing so happily that by laughing, he was laughing fully up to his heart. And when he was laughing, he was thinking that my red blood cells, the cancer cells are dying day by day, day by day, day by day. And he lived for more than 86 years old, and which is given in his novel, that the anatomy of an illness. So he has given this book, it is available also. So he has written that how the positive mindset can, even a cancer can subside from you. That is the biggest challenge today. Is this. That is why heartily laughter is a good way of jog internally without having go to outdoor. So every day he will see the movie and enjoy the movie, and that way, this completely way he became cured. So let us come to the mind. Mind capacity, if you see, tremendous. Even 10 supercomputer cannot do a simple work. For example, you have 10 to the power 15 operations per second without your knowledge. You do not know anything, but mind is going on. Maintaining blood pressure exactly in the vein, whatever requirement, the temperature of the body, the internal, all the internal objects everywhere. There are lot of complexity. We cannot understand this. Although so many PhDs are there, still there are a lot of things which we are not able to understand. So core body temperature is maintained and continuous heartbeat. Even while sleeping, you have no consciousness. Still that time, your continuously heartbeat is going on. And 150 trillion synapses, 85 billion neural cells active in every second, which is, if you think also, it is so big actually, like a sky. Sky, you see, unlimited. Similarly, the functions which is carried out in your body is so unlimited also. That is why there are different, when you get the message in the, by your mind through the senses, these 5 senses, then there is a subconsciousness mind which makes that was a habit. For example, I will give, every day you come from the office, and in the office, when you come back, what you do? You want to drink a cup of tea, and after drinking cup of tea, then you require some snacks and you watch TV. So you do for 1 month. After that, you will see that when you come home, without getting these three things, your mind will always poke, like, oh, you are not getting tea, you are not getting some food, you are not watching TV. So this became your habit. So habit is developed due to the repetitive. So in the mind, what it happened? In the one of the synapses that became a like shortcut you give in a computer. In the computer desktop, you just click it, it will take you directly to that file. That is called the shortcut. Similarly, in the mind, a shortcut is created, and that is called the habit. Initially, the mind is very, very difficult, but slowly, it will become. For example, the backup of the mind, school children, they see today, because of this television, they see 8,000 murderers when they finish their school, and 1 lakh act of violence when they finish their school. By that time they watch. So that is why you are seeing that even the lot of sinful actions are going on, our children are not, because they are seeing always. I remember one of my friend's son, it in Raipur, and he was watching the TV, and one hero was killing one after another in one shot, and he was enjoying, and he was telling, what a shot, what a shot. I told, what you see? Do you see? In one time, he has killed 4 people at a time. So the mind, when it is inserted there, it is when the mind it is inserted, it is very difficult to remove. And when it is acting, that is why positive thing has a higher vibration frequency and negative thing has a lower vibration frequency in our mind. I will tell a very beautiful story. So this story is about a great sage. His name is, it is in the Srimad Bhagavatam, 9th canto, chapter 6. So Savari, Savari Rusi. So there was a Rusi, he was intensive renunciant in the history. So this Savari Rusi, every day he was staying in Vrindavan, and every day he used to practice the renunciation, the samadhi, okay, Jal Samadhi. Jal Samadhi means he will go inside the Yamuna river. In the bottom of Yamuna river, he will sit there and practice this samadhi, that how to control the senses within the water. Because you have seen the great yogis outside the water or in the Uttarakhand, in the Himalayan mountain, but he used to go inside the water so that nobody can disturb him. He can practice very nicely. So once, while he was doing the austerity or by doing Jala Samadhi, that time he opened his eyes, and that time 2 fish, they were mating each other. One male and female fish, they were mating each other. And then Saubhari Muni saw this disturbing situation. And then Saubhari Muni came out and desiring that I must, because in his backup mind, he created some kind of the desire. That desire need to be fulfilled. So directly he came out from the water and went directly to the King Mandhata. Okay, he was the king that time, he came to the court of Mandhata, King Mandhata. And he told to king that, my dear king, I have a desire to marry. I want to marry. So Mandhata asked, my dear sir, because he's a great Rishi, because Rishi had so much power. So Mandhata told, yes, please tell to whom you will marry. So he told that, I want to marry one of your daughter. So Mandhata thought, she is a very old, and he became very astonished. Is a very old and doing austerity. When you do tapasya, you will not look very good actually. So you can see this picture, Mandhata thought that, oh, he will marry to my daughter. My daughter's life will be ruined. He told, you give me one daughter. You have 50 daughters, you give one. So Mandhata thought that my daughters will not like this figure. So he told that, yes, tomorrow, if my daughters will be agreed, then you can marry. So Saubhari Rishi, he told to King Mandhata that, okay, tomorrow I am coming and I will see your daughters. Who will agree, she will marry. And next day, Saubhari Rishi, because he was a great yogi, he understood. So he made himself a very beautiful personality. And Saubhari Rishi reached in the court of Mandhata in the next day morning. And Mandhata called. He saw that, oh, Saubhari is coming very beautiful. He was looking like a great sage, a great king. So as soon as, because he had yogic power, by yogic power they could able to do any kind of manifestation they can do. So he was a great yogi. That's why in the previous age, the yogis were so powerful, they could able to create a moving aeroplane on the space without any material element. That is possible with the yogis. But nowadays, the yogas we do for our health only. If somebody became fat, they do yoga. Somebody is some pain, they do yoga. Yoga is not for doing the physical exercise. Yoga indriya sanjama tatha jigyan yoginam api sarvesam madgata antaratmana shraddhavan bhajate. Yogi, those who are always remembering the Supreme Lord, Krishna's name, they are the perfect yogis. So anyway, he came with a very beautiful person, and when Mandhata called, all his daughters, all daughters told, oh, we will marry. 50 daughters they told, we will marry. Then the king was thinking that how he will manage. He was a sage and he transformed into a young man, and how he will manage. Because Saubhari Rishi has lost of tapasya. So what he do? He manufactured himself into 50 Saubhari Munis. And at the same time, he built 50 houses, very beautiful houses. So king astonished. And in each house, he put one wife and he stayed with that wife. And each wife has hundreds of sons. And each hundreds of sons has 100 sons more. And they stayed, that became a big kingdom. So you see, then one day, after thousands of years, Saubhari Muni was thinking that I went there for this, for practicing this one, but today I went there for practicing for self-realization, but I have forgotten that one. You see, this is the mind. Mind can misdirect anytime. That is why he says here, ekastaparasavyaham hambasi yassa sabgat paschada samuta paschad sahasra sarga santam brajam bhuva yakurta manorathanam maya gunai Ratamati Visayetha Bhavaha. In the beginning, I was alone and engaged in performing austerity of my mystic yoga. But later, because of the association with fish engaged in sex, I desired to marry. Then I became a husband of 50 wives, and in each of them I begot 100 sons. And thus my family increased to 5,000 members. By the influence of the modes of material nature, I became fallen and thought that I would be happy in material life. Thus, there is no end my material desire, so enjoyment in this life and the next. So when you want some material enjoyment, for example, that will give you material enjoyment for short time, but in turn, it will come very voraciously, double the material taste you required. Again, you control, do that one, again, you require more material sense enjoyment. So like that, it's one fold after another, one fold after another. In the material mind will never satiate you. That is why we should have very extremely careful while listening music, while controlling our thoughts and associating with people. That is our thought creators. So that is how the mind, I could not able to show. There is a nice video. So you can see this video of Charlie Chaplin. So I have taken this one as how the mind, maybe just 1 minute, I will make it a full screen so that you all can release this video. Okay. So we have seen here that mind is like a machine. When machine is very rightly it is operating, then everything is very fine. If the machine is not properly operating, it is disturbing us. Exactly, the mind is exactly like that. That is why in the youth time, when you need to mind have to develop some kind of the beauty of this life that you can enjoy in every step of your life. That is why we have more desire, more extra endeavor, extra way of controlling. That is makes us more distress. So youth is a time for mind, body, spirit to be nurtured and developed through discipline. Youth is not for undiscipline. You know, the youthful time is not for enjoyment, but for enlightenment. You see, there are great stories of Prahlad Maharaj in the youth time, and even Narada Muni, the youth time, they have engaged very nicely in the practice sadhana of how to control the mind. Unfortunately, there is no today in the school, we don't teach any self-control, nor the parents we teach also any self-control. We teach that, oh, you should come to IIT, you should get into IIT. That is our main goal, but you do not know that nearly 60% of the IIT students, they are misguided and very immoral in their character. If you see them, because of that one, it is very essential to teach them the basic knowledge of the ethics, philosophy, and religion. And no course are there today in this, especially in India, which was removed from the course, which is very much essential, which will build the life of the person. You can do very good. I am a very good engineer. I get my lively earning. After that, what I do? So that is the most important thing. That is why in the Bhagavad Gita, there is a very beautiful statement. And it says here, Bandhuratmatmanastasya yenatma vatmanaditaha anatmanastu satrutve vartimanvitvava satruvat. If you see here, for him who has conquered the mind is the best friend. But one who has failed to do so, his mind will remain the greatest enemy. So how to achieve success? There are, first thing is positive thinking. And second one is responsibility. Third one is inspiration. Fourth one, knowledge. Fifth one is the discipline. First, I will tell the positive thinking. Like there was a gentleman. He always come and tell one gentleman. There were two neighbors. So one gentleman, I was thinking that whatever we have a dirty thing, I should take and throw to other side. And the other side gentleman, he will clean that one, that garbage, and then he had a lot of fruit in his mango tree. He will take a basket of fruit and go to other's house and will tell that, please, my dear sir, whatever you had, you have given me, but we have these mangoes, please take it. So every day he was giving, but that neighbor, every day he was throwing. So the neighbor, one day he thought that I throw all the dustbin on their side, but he gives me a better thing. Then he thought that I am in the lower position than him, so I should go and ask forgiveness. And from that day, he never did that one. But if you see, you will become also envious to that neighbor and start thinking, he is destroying me, let me destroy. Then you will also destroyed by that process. Example, there was two neighbors, and one neighbor got a lottery of 1 crore rupees. So second neighbor thought that 1 crore rupees, he got the lottery, he will do everything very nicely. So he prayed to the Lord, my dear Lord, please became, so when he prayed, then God came and God told, what you want? He told that whatever my neighbor they have, you give as a double. So suddenly God told Tathastu. So God gave blessing. And then what he did, he first he got 1 crore. So he got also 2 crores because he was asking for that. And then he got 1 house. He got 2 houses suddenly. And one day he got a bike. He got 2 bikes. And after some time, this person was going in the bike, there was an accident, and 1 hand imputed. So this person, 2 hands removed. So this is when you think for wrong about others, you will also get the same thing. You should never think that, oh, you think like that. So that is why God gives responsibility how much you can take. That is why I will tell very instructive story. Once there was a pond. In that pond, the people were taking bath very nicely. But one person, one student, one small child, he was sitting very morosely and looking at them. He was not happy because his friends were taking bath and he could not able to. So he was very morose. He was sitting. And in that way, Lord Shiva and Mother Parvati, they used to go. While traveling, Mother Parvati told that why this boy is very morose and he's sitting here, he should go and participate with that. Then Lord Shiva told, you please look how he can, you look at that boy. So he says, that boy has no hand, so he cannot swim. So he has no hand, that is why he cannot swim. So Mother Parvati told, he is very sad. So please give me 2 hands. So Lord Shiva told, no, this is because of his action in the previous life. That's why he don't have a hand. So, but Mother Parvati is a mother. So she requested Lord Shiva, please give actually 2 hands. So Lord Shiva gave a hand, then they left that place. After some day, they came back and they were passing by that road. And that boy to whom they gave hand, he alone is swimming, others are sitting outside. Then Father Parvati asked that why he is sitting, they all are sitting outside, now he alone take swimming. So Lord Shiva told, because his character is, he is drowning everyone inside water. That is why everybody is fearful of him. That is why whatever action we do, the same kind of reaction we must get. That is why human birth is for responsibility. We are not like animals that we are, because when we do the 4 things common between human being and animal, that is called ahar, nidra, bhaya, maithunamta, etad manusya pasubhi samana, dharma hi eka asesa visesa, dharma nahi na pasubhi samana. This is said, this is the responsibility. Ahar, eating, sleeping, mating, defending is common between human being and the animals. What is extra? Dharma. Dharma nahina pasubhi saman. That you can understand what is God, what is Bhagavad Gita, what is Bhagavata. So inspiration is the key. Like, if I will give an example, inspiration is our Einstein. He's a great inspiration person. And if you see his life, he was not so good in the school, he was not so good in college, but how he could able to give such a beautiful theory, which human history will never forget. That is the key of inspiration. And that inspiration comes from our, for example, if you want to study, that inspiration will automatically develop. And then we have knowledge. You must gain the knowledge. Knowledge means by which you can understand who you are. What is the purpose of coming to this material world? When we work hard, we are always striving for happiness. Why distress come to us? We do not want death. Why death come to us? We do not want old age. Why old age come? We do not want disease. Why disease come? That is knowledge. Who we are. What is the purpose? That is the knowledge. Knowledge is not physics, chemistry. These are the knowledge for our food. But the real knowledge is which will transform you, which will free you from the birth, death, old age, and disease. That's why second thing is your discipline. Anywhere, if you are not disciplined, you cannot develop. Even our students, they are doing PhD. They come at early morning and 8 o'clock, 8:30, 9 o'clock, they should reach and they study whole day. That is discipline. That school children, they go to school at 8:30, getting up early in the morning. They stay to school 1 o'clock, again come. Those are discipline. So anything we want to do, there must be discipline. So what is the first step to control the mind? Do not allow the senses to go here and there. Do not allow your senses to wander astray any direction they want. You try to control it, because if you want to control it, you want to use a little bit, that sense force will come reverse, double power. So you cannot stop it. So that is why do not allow your senses. Second one, engage your senses and mind in the topics of God or inspiring personalities. You must think. Don't think that, oh, you see, like Professor APJ Abdul Kalam. Very inspiring personality by which you can understand that what is science and both the spiritual science, both are in one person. So engage in the senses, in the mind, the topics of God. Or you can see here, Srila Prabhupada, A.C. Bhaktivedanta Swami Prabhupada, who has completely transformed throughout the world. He has given what? The love of Godhead. He has given love of Godhead. He has now 876 centers all over the world, where each center, they are feeding 1,000 plates of food, to sanctified food, to the people in general, they distribute everywhere. That is why the second thing, we must not read a novel which will create your passionate activities. You must give this one. And third step, understand the meaning of life by reading thought-provoking books like Bhagavad Gita, Srimad Bhagavatam, the science of self-realization. These books gives the complete knowledge, because they are the desired tree. Why desired tree? Because there are all kind of knowledge is available there. You want to become an Arjun? So like Arjun 5,000 years back, all the princes were called by the sage, told. He put it in the top of the tree, there was a bird. He asked first, he called to first prince, told, what you are looking? He told, I am looking a big tree. He called to second prince, what you look? I look the branch and lot of leaves. And third one he called, he told, where you are looking? No, I am looking trunk and the leaf, and there is also bird. And fourth one he called, he told, yes, I look bird, trunk, and entire tree. And fifth one he called, what you look? He told, I look this eyes of that bird. Yes, he rejected everyone, and he gave instruction. Yes, he can become a great archer like Arjun. So that is why you can see what is the concentration power of Arjun, that he was looking below and want to fire or want to fire the arrow to the top where the fish is moving. So this is how the concentration power, when you want try to understand this thought-provoking books, these books are given how to concentrate, how to, like these books are manual of life, because people that don't read this book, they do not understand what is the manual. For example, you purchase a mobile, along with the mobile there is this, along with this mobile you get a manual. This manual, according to manual, you have to operate this mobile, else the mobile will damage. Similarly, this life is meant for this, and these are the life's manual. And when you don't have knowledge, then you should not say. For example, there was a very poor man, he is illiterate in a village. The first time came and saw there is a big train is moving. Oh, the train is very lengthy. So I can also travel in the train. So he do not know anything. So he entered in the train. When he went inside the train, the TT came and asked, "What are you doing? Where is your ticket? Show me ticket." He told, "No, sir, I do not know. I am illiterate. I am from that village. I never seen train. So I entered here like this." So he told, no, you made a mistake. You have to go to jail. So TT will take to the jail. So this is whether you know it or don't know it. If you put your hand on the fire, your hand will burn. Similarly, these books are also exactly like that. The Srimad Bhagavatam, Bhagavad Gita, these are books, gives the life's teaching. And they will, by studying these books, you will become a complete man, which both spiritual and material thing together will constitute. For example, if you have only material activities of eating, sleeping, mating, defending, can you think anything else? You can never think. Like you eat only lot of food up to your neck, and there is no water, there is no air, you will get indigestion. But when you put 50% food, 25% water, 25% air, automatically your digestion power will be very high. It will develop more high. So that must be this one. Only you are doing material activities, that will make you distressed. But when you do these spiritual activities, that will make more. Then next is our associating with a positive minded person who inspires you or who is trying to control his mind. Like those who are trying to control the mind, you should associate with them. But don't associate with people, those who are not associated, those who are, that is why you must associate with positive minded people. Like just a little bit association can damage your entire thing. Okay. For example, I will tell that in the corona time, so when there is a corona patient, so exactly we corona people just nearby, you will get infected. That is called the infection. So we should try to control our mind. So then how you will control? Make best use of human life by giving others and bringing smile on others' face. So this is the most important thing. Okay. So just a minute. So, is it audible?
Yes, sir. Yes, sir. You are audible, sir.
Okay. So make best use of the human life for giving. Uddhan sir? Hello?
Yes, sir. Yes, sir.
Hello?
Yes, sir.
Hello? Hello?
Yes, sir. You are audible, sir.
Hello?
Yes, sir. You
Okay.
are audible, sir.
Hello?
Sir, we are able to hear you, sir.
Okay. So make the best use of human life by taking care of others, by giving others, bringing smile on others' face. You will become very, very happy. Very happy because this is your responsibility. If you have more, you distribute to others, that everybody will become very happy. There are how to teach the mind control. We try to control the mind by the chanting. This Maha Mantra is one of the greatest thing that you can chant. This Maha Mantra, this Hare Krishna, Krishna Krishna, Hare Hare Ram, Ram Ram, Hare Hare. By this one, so there are a lot of programs which we do with our students that they try to learn it by their own endeavor, and they could able to see that in their life they are also became very conscious. So that is how we teach the people by doing our service. So the most important thing is that benefit of control mind is the mind, the cool mind. Mind became very cool, peaceful, clear intelligence, purified senses, and better concentration and memory, and more efficient your mind will become. That is why every student, every faculty, everyone must be taught the science of this mind control. And that is what in the Bhagavad Gita, so in the Bhagavad Gita, there is a statement that which is a very beautiful statement, and that is that Vidya Vinaya Sampanne Brahmana Gabhihastini Sunichena Sapakecha Panditaha Samadarshina. So this is in the Bhagavad Gita, the humble sage by virtue of true knowledge sees equal vision, a land and gentle Brahmana, a cow, an elephant, a dog, and a dog eater. So anyone you see, you must have respect for them. It is to a Brahmin, you give respect, to a cow, you give respect, an elephant, a dog eater. Everyone, you must give respect. This is actually Vidya Vinaya Sampanna. Vinaya means you must become humble by learning the science. Because if we are learning, we become Pandita, that I am a PhD. If I became very proud, oh, I am a big PhD, I did like this, then I am not actually, actually I am not a Pandita. I am low grade. Vidya must demonstrate your humbleness so that you can see everyone and the equal vision. Cannot distinguish. Oh, he's a big man, he's a small. Everybody, you must give respect to everyone. And this is the achievement of all Pandita. Pandita is not to take birth in a Brahmin family, Kshatriya family, Vaishya family, Sudra. So Krishna in Bhagavad Gita, he says, the Chaturvarna Maya Sushta Guna Karma Vibhagasa. 4 varna I created according to guna and karma. So we all must learn this one. When you become a humble, you are real Pandita. When you are become humble, like you have a teaching your student, you must go to their level of understanding. So automatically you will see that you are very humble. Student will like you so much. Faculties also, students also should must imbibe those qualities by which they can become a beautiful personality in their life. Thank you very much. If any questions or comment, we can discuss.
Thank you, sir. Thank you so much. From audience, if you have any questions, please, you may discuss with the speaker.
Hello.
Yes, please. Yes, you may ask the question, please.
So somebody put in the
Yes,
chat, let
Yes.
me.
How to avoid negative emotions or thoughts in day-to-day life? This is the question, sir.
Okay. Okay. So Dr. Nagaraju. Okay. Thank you, sir, for asking beautiful question. How to avoid negative emotion or thought in a day-to-day life? Because first thing is our association. So association actually makes our everything, because if four people will tell you in front of you, they think negatively, you will also think. So how to convert that one in a positive thought? So the association is the most important thing. There was a lady, her name was Mary in the England. So Mary was suffering. What he did, he had tuberculosis that time. There was a disease. So this Mary, wherever he will go, she will touch others, and he will get that disease, and he immune to that disease. So he carries that disease and go and touch. Like in our India, there was a Vishakanya, means poison girl. In the Vishakanya, this Vishakanya used to, from the childhood, the king used to feed little poison. And when she became an adult, that time whole body is poisonous. So wherever, if some other king, they will fight, this king will send. You go to that king, and when that king will come, and just that king give some, like a touching that girl, as soon as it touch, because poisonous, so that poisonous effect can be. So, but because of association, but you need to put the curtain. How to put curtain? Because we don't have engagement, proper engagement we do not have. So we do not have proper engagement. From the engagement, you can avoid this negative emotion. For example, somebody come and tell you, for even the house also, everybody is not equal. So everybody in the house also, many people will come and tell, आप तो जो किए हैं अच्छा नहीं किए. So you can tell, my dear friend or my dear family member, my dear friend or my dear brother, yes, whatever capacity I had, I have done for you. If I could not able to do, please forgive me. This is the biggest thing you can control immediately about the negative emotion. If you will tell that, oh, I have done this, I have not done this, so that will create more and more. Like one professor, one day he came, he told me that I am very envious of you, and I want to, I told, For what you can be envious? I have no quality, good quality, nor I have so much achievement. I have nothing. So why you will envious to me? I know that you love me so much. The same thing what he told, the next time he never repeated that. That is why, sir, please take it positively. When somebody will tell, like I invited somebody here, one professor, and that professor, that my invitation card in front of me, he teared and he threw to the ground. And then I took all this that he teared it and throw. So I collected that and put in my pocket, and I hugged him. I told, thank you so much, sir. So next time, he became so good friend next day. That is our life. So more we want to dig, it will like a scratching. If you do scratching little bit, if you have some kind of scratch, so you want to scratching, it will become more blood will come. That is why, please, that is why we need to take very beautiful thing as a positively every aspect of your life. Do not lead it to further degradation or further anxiety. Okay. So if I could able to answer you, if you need more question, you can write me to my mail or my mobile number. For this purpose, I can give my mobile number also. So you can directly call to me. For this purpose, I am there. Okay.
Sir, another question is there in chat box.
Okay, sir, I am vegetarian, but it comes in my mind is that eating non-veg is sin. As anything vegetarian we eat is also a living being. Yes, my dear sir, if we see the anatomical study of a human being, you see, the anatomical study means you drink the water like a cow drink the water. You don't drink the water like a cat or like a dog or like a tiger drink in the tongue. They drink the water because they require less water and their body must be more acidic. Our body is 7.5 pH value, which is more into the alkaline. That is why we are distinguished from the vegetarianism and non-vegetarianism. So you may say that many people eat non-vegetarian. They eat. There is a big scientific journal in the England School Medical Science. They have given that by eating the red blood cells create the holes in your stomach. It creates a lot of big holes in your, because the sargonic acid which produces by this non-vegetarian food cannot be digested by our intestine. So they pass through your urinal structure directly through the kidney. That's why kidney failure is one of the most important factor in the human life. You may be in the youth, you are not having. In the old age, there will be small hole will be created which will damage your kidney by constantly passing the sargonic acid through this one. That is why the human being is not to be consumed non-vegetarian food, because their intestine, they are not acidic in nature, they are alkaline. Those who are acidic in nature, then they can have the food which they have digestive power, but we do not have digestive power. Even you drink exactly like a cow drink, and becoming vegetarian is not all in all. That becoming vegetarian also, if you see, our tiger is, elephant is vegetarian, and monkeys also vegetarian. Vegetarian, yes, we are also eating the living, vegetarian also living. But it is said in Bhagavad Gita that pachanti atma, tegham papam pachante atma karan. Who prepares food for their self consumption, they only eat the sin. But when you eat that food is offered to the Lord. That's why prasadam. When you eat prasadam by offering to the Lord, that becomes sanctified. How you know? Because as soon as you offer that food by putting a tulsi leaf, automatically that food taste increases many thousand times. Go to Tirupati Balaji, thousands of plates of prasadam is given every day. So those food will create your body and soul together. It improve your consciousness. And that is why, but there is a difference in the vegetarian. For example, there is a house, in the fridge, there are a lot of vegetables. And there are also people. That house got fired. So anybody will go and save the vegetable, they will save the human beings. They will save the living entity who are there in that house. That is why it is not common. Many people, they say that we can, the vegetarian, when there is a fire, you save first the human beings. Anybody goes, oh, aloo 4 kilo was there, let me save only first aloo. Nobody goes. Okay, that is why the vegetarian, you are very good that it is vegetarian, and you are not actually destroying your health anymore. That is very good, but also offer and take. That will be more good. Okay, thank you, sir.
Any more questions from audience?
Another question from Vibhu Prasad Nanda, sir. Okay, thank you, sir, for your question. Is attitude mandatory for improvement in a day-to-day life? Because attitude sometimes returns a value which is not deserved by a person. Yes, it is always. So, but when you, this attitude, every time you come, for example, I remember once in the IIT Kanpur when I was studying, that time we went, there was one professor, he is now in IIT Delhi. He was a student also, I was also a student. So we went to collect some fund for the Janmashtami. So we asked one person, they were drinking in the one room, 10, 15 people, they were sitting together and drinking wine. So I asked them, my dear sir, would you like to give some contribution? They told, no, get out, your beggars are not allowed. Beggars, we don't give any money. So because other person, he was from some, he became very angry, that Dr. Singh. He became so angry that I will kill these people. I told, no, we came here for asking something. And they have not given, that is good, no problem. So I came back and told, please come on that day. So like that, but those people, by that, because they have this attitude, so the attitude you cannot change everyone's, but you can change your attitude. So when I have like that, so I told after 3-4 days, his name was Prakash, he was Biswal. Biswal came and told me, sir, I am sorry, I was on that day, I was not good, so I did like this. So we need not to change others' attitude, okay? But you can improve your attitude by tolerant. This is given in the Chaitanya Mahaprabhu, he has given in his Sikhyatakam, Trunadapi Sunichena, Tarorapi Sahistuna, Amanina Manadena, Kirtanya Sadahari. He says, Trunadapi Sunichena, you must feel that I am the lower than a blade of glass. Tarorapi Sahistuna, like a tree, you cut a tree never give you complaint. Why you are cutting my tree? No. It's like that we must be tolerant. Amanina manadena. One may not give respect to you, but you must give respect to others. Then Kirtaniya Sadahari, that person can always chant the glories of Lord Krishna. These are the characteristics, because we must take from this Vedic knowledge. That is why I recommended these books. Please take. It is available online also, and I will share also if you require the PPT of the technical also I will share with SAR. He will circulate to everyone, and I will also share this one with the sir, so you can look into it.
Okay, sir.
Positivity improves attitude or not? Yes, positivity will improve everything. Everything in your overall structure improvement will take place by just by positive thinking. Because we look everywhere in negative thing, that is why there is a problem. Is drinking animal meat good for us? Any animal doesn't drink milk other than his mother, but human drink animal milk whole life. Yes, very good question. And any animal does not drink? Oh yes, thank you very much. What is his name? I must thank him. And that Dr. Vaibhav Prakash Srivastava. Thank you very much.
He is master student, sir. He is master student from this institute. Yes.
Okay, okay. Thank you very much, Vaibhav. Very nice question. Okay. Yes, we drink. You see, in the cow, because I am going to start a Gosala within 2-3 months. So the cow, when the bull is not used in the for at least 60% of the time, the bull will become a diseased one. Similarly, cow milk, it is not all the milk. It is only human consumption cow milk, because the cow milk will give you, it will make your finer tissue. You can read one article, it is there. I think it is in the Boston School of Medical Science or Caltech Medical School. I don't know where it is. There are actually that with your cow milk, your tissue became finer to understand the topics about the God consciousness. And other milk are there you can use. In our village, they use the goat milk, many milk. But the human consumption, the cow milk are given. And cow, that is why another name of cow is our mother. There are, in India, there are 5 mothers. Rajapatni means king's wife is our mother. Our mother is our mother. Cow is a mother. Dhai was taken, our nurse is our mother, and the earth is our mother. So these are the 5 mothers, and the cow is one of our mother, because if you will feed the cow's child full milk, for example, cow is giving 4 liters. If the cow child cannot eat 4 liters, when she eat all the milk, they will start vomiting. That is why the cows, they give more grass and less milk to the cow child, okay, calf. They feed very less amount. Why? Because if they drink full, then they will start vomiting. They will become diseased. This is not human made. You see, cow eat only grass, zero vitamin, but gives the milk which is having full vitamin. Today, why people are thinking the desi cow, desi cow, desi cow? You go in America, one of my students, and she bring me and give a big barrel of ghee. She told that, sir, you don't drink anything. You don't eat any oil, you eat this ghee. I told, how you produce so much ghee? He told, no, here Jersey, they give so much ghee. But in India, we have a very small amount of cow, and they are like amrut. That is why. So, so it is good for milk, drinking the cow's milk. Okay, that cow's milk can also stop your diabetes, sugar, many things. That lot of benefits actually. So I will tell you the whole, and that is why the human being, they can drink the milk of the cows. Okay.
Okay, sir. I think there is no more questions. Maybe they will be writing. Okay, sir. Thank you, sir. I have 2 small questions, sir. Basically, like both questions are related to each other. Like how to forget the moment which doesn't deserve to be reminded. Like we have done something wrong thing in past. We don't want to remind it, but used to be reminded many times, and that creates another like a repetition in the mind. So how to avoid those things?
Most first thing you must do, my own experience I will tell. Okay, few days back there was some problem. Okay, in the somewhere, so my mind got disturbed. So I generally gets up early morning 3 o'clock or 4 o'clock, maximum by 4 I get up. But that day I got up at around 12:30. Okay, so I slept 11 and 12:30 I got up, and I had that one into mind. So I was thinking that as soon as that thing came into mind, I didn't get again the sleep. Okay, so what I did, I took my chanting mala and seated and chanted very loudly. And when I chanted, and after that, sometime I completely forget, then I doesn't allow my mind to remember that thing and try to control that mind thinking about something else. Like you like your child. You think, oh, my child was playing and like this. That is give you more happiness. You like your wife's some activities. You think that one. But the most beautiful activity is that some Lord Krishna's activity. You, while sleeping, you just think it, you will see that you will immediately will be drive away. Or if you are in that position, you are getting like that, you should leave that place. If you can control, control it. If you cannot control, you leave that place for some time and come back. If you stay there, that will create more distress in your mind. So immediately you leave that place, go and move around and come back at that place. You will see that your temperament level, which was 50%, it will reduce to less than 10%. So these are the positive ways of avoiding sometime. Sometime you see in the family or in friends, everywhere, like this time comes, but you must leave them. For example, for the 2 days back, many professors, they were talking something. So I understood that if I will go there, I will something have to hear. So I left in other route so that nobody can call me and nobody can go. So sometimes knowingly we should avoid, or you see that somebody always speaks something nonsense, you try to avoid him. When you see, okay, hello, that is how it is.
Okay, sir. Okay, thank you so much, sir. And
Okay.
sir, second
So,
is
sir,
small
I will
question.
send both the PPT to you. You can
Okay,
share
okay, sir.
all of them. Okay.
Okay. Sure, sir. Okay, sir. I had another small question. Shall I ask or you have to leave, sir?
Please. This question can go up to 9 o'clock. No problem.
Okay. Thank you, sir. Sir, like how to stay in present situation? People mostly used to go in either in past or in the future planning or something like that. So
Yeah.
how to put mind in the future situation? What I am doing, I should enjoy that work, not think or rethink about the past or future like that.
Very good question, sir. Actually, in the Srimad Bhagavatam also, there is a statement that in the Kali Yuga, people, they for present, they are unsatisfied. For the past, they are always distressed. Okay, they are not happy for the past. For present, they are not satisfied, and for the future, they are anxious. Okay, but if you are God conscious, sir, you will understand that, oh, my life can go anytime, because you think that, oh, tomorrow I will do like this, but you don't know whether you will get happiness or not. Many people, they study in IIT, and when they became the adult, by that time they get so much disease, they cannot even enjoy whatever they are studying also. So what to speak of enjoying happiness? That is why whatever God has given you, you must praise to the God. That is the most important thing in our life. For example, there was a beggar, and beggar, he thanks to God. He saw, while going in the street, he saw to a diseased person. He thanks to God, oh my dear God, you have not given me. Although I am a beggar, I am better than this. Thanks a God, my dear Lord. Thank you so much. And the diseased person was going and he saw a mad fellow. He jumping like in the street. So this person, he thanks to God, oh my God, you have given me disease, but this mad fellow is going, you have not given mad me, this, you have not make me mad fellow. So thank you so much. And the mad fellow was saying there was a dead body going. So mad fellow also praying to God, my dear Lord, thank you so much that this, I have not dead, at least I have my life to glorify you. And this is the present situation with the earth. If you can glorify whatever situation you have as a better situation, then you can glorify the Lord all the time and you can live in the present situation always. And that is what I came here a long back in the NIT Raukela. I used to go to clean the leprosies, okay, leprosy people. They had a lot of disease actually. So I used to go them and used to clean their fingers. And while cleaning, the finger will come out sometime. So my friends will tell, Are, you will get leprosy, why you are touching them? But I have seen them, that they are so beautiful personalities. And I was never worried because I know that when God will give, you will get some kind of disease. Else it is not possible. So we should take care and we should do the things. That's why every time we must glorify the Lord. Then you will see that you are living and every time in the present situation. You will never worry for tomorrow what will happen. Okay.
Thank you, sir. Any more questions from audience side? If there is no more questions, sir, then we can wrap up it. So once again, thank you so much, sir, for your very nice talk, and really it will be helpful for the persons who will be following the things. It is not easy task to be calm when someone is retreating against you. But I think if we are trying, we will try slowly, it can be possible for some level. So thank you so much, sir, once again for your nice talk and giving time. Thank you so much, sir.
Thank you, sir. Namaskar.
Namaskar, sir. So all the participants, now we can close today's session. So tomorrow we will start at 10. So thank you so much for participating for all the 3 sessions. Thank you once again. Thank you so much. Now we can close it. So thank you so much to everyone, all the participants.